end at descriptors that are used to describe divinity. Infinite amounts of time, things perfectly being put together, you know, quantum. Somebody talked about quantum earlier, and it's when you get to the bottom of that, well, how do they define a field? Well, they define a field as something that, quote, has a value at every point in space. Oh, so you mean like an ever-present background medium like the ether? Okay, yeah.
Speaking of the ether, did Shane and Alan really just get run away from the cell nav after Q-Op confronted them that one time?
I don't know. Do you stop to fight with dogs that bark at you through a fence?
Wait, what happened?
No, I don't know what you're talking about. First of all, Q-Op is just a fucking liar, by the way. In his video, he totally misrepresented me and his conversation, just so you know. And if you want to see the whole thing between me and him, because he's actually just like the TMZ of Flat Earth. That's what he's trying to be.
No, Alan fully packed it up and doesn't do it anymore since Q-Op confronted him.
Well, that's just wrong. They're focusing on the null hypothesis.
100% is true. I literally watched the last episode you guys ever did, and Q-Op confronted you guys, and then there was never an episode after that. So that is not wrong. That is objectively what happened.
Yeah, but it has nothing to do with Q-Op. Literally has nothing to do with Q-Op.
That's coincidence.
That's what you said about Vapegate, though.
You're a coincidence theorist.
Yeah, Alan took a break, but he's actually going to be doing a new show on Monday, coming soon. And he will be.
Cellnav's coming back?
He will be. It is a new show. It is not a Cellnav show, but it is a new show. And he will be doing special Cellnav updates as well, and may do updates during that show, depending on exactly how he's going to work it out. But yep, there's a new show coming. So
Cellnav's coming back.
Nothing ended. Because people take a break, it doesn't mean something ended. People get so dramatic, like, oh, it's over, it's ended. It's like, bro, this is life. People take breaks, things go in and out, the tides come in and out. There's different times for different things. Alan's taken breaks in the past, even from the Cellnav thing. He's taken 2-3 weeks off. He's doing that show, so.
How many weeks off?
Look at Lemon Bird. He's probably dead, right?
What?
Of course, dude, you're probably Lemon Bird with a fucking voice changer.
Jake's a pain. Dude, they've done 36. Most of the commentary that I'm hearing, people are just kind of like, oh, what number are we up to now? Why is he going for so long? That seems to be most of the commentary.
Yeah, exactly. I know people were like, oh, this is so boring, so terrible. All the Globe guys and people just complaining. And then now that it's not happening, they're like, oh, it's over. He gave up. Every single comment is just this dehumanizing, just sociopathy. Just constant dehumanizing, rude, disparaging energy people have. Where's our humanity? What happened to just being a human and having some level of respect for another human being?
It's gossip. Noah loves pointing out when people gossip, but
I think the Cellnav, I don't know. From my understanding, there ain't no more Cellnavs. I mean, if there's going to be another one, let me know. I've not been able to participate in one of them.
Well, you got bad timing then.
And every time that I have asked for a Steelman of it, the Globers have hopped up to do a Steelman. It sounded pretty dumb. And none of the Flat Earthers have actually Steelman the Celestial Theodolite to me once. So I've never been on the show. It's never been Steelman to me by a Flat Earther. All I've ever had was hostile Steelman. So
why is that anybody's fault except your own? Just show up on Monday.
Because I come here and I
watch the fucking live stream,
it.
guy. Yeah, but you could just
watch the
live stream.
Can you Steelman it?
You could Steelman it if you just went on the live stream and you actually gave a shit instead of pretending like, oh, I haven't got.
I don't care. It's just shit talk for me to get this information. Can anyone actually Steelman it?
No, it
is. It's just straight up shit talk.
I didn't think so. Not worth my time. I didn't think so.
Wait, Steelman what? My bad. I was AFK.
So you might be the perfect guy to do it, actually, Beasticles. From what I heard, you're the only guy who can actually Steelman it.
Steelman what? Celtio?
Yes.
Oh, it's pretty simple, bro.
Jesse Path of Light Steelmanned it to me, but I don't know if it's what he told me was a legit Steelman.
That dude's a snake.
But that's the most legit Steelman I've heard yet. Is the one from Jesse Path of Light.
It's so simple.
I understand that there's 2 observers. One observer's on the ground, one observer's on a mountain, something like that.
Yeah, so basically you're testing the internal consistency of their system, right? And their system is the stars are at a fixed position in the sky at a certain time, right? And there's a certain rate that star will move across the sky, right? 15.04 degrees per hour. Okay? You with me so far?
Yeah, I'm with you so far. Are you gonna go through it right now? Because I can take a seat back.
Actually, hold on. I'm playing Arc Raiders. Hold on.
No, it's like the new game, bro. Everyone plays that shit.
Oh, it's so fun, dude. Hold on, I'll be right back.
Well, let me know when you can Steelman it, bro, because I'm waiting. From what Jesse and QOP told me, it sounds pretty bunk.
I'd definitely be interested to hear if any other flat earther can Steelman it besides Beasticles.
Steelman what?
Yeah, people can emotionally fight for it, but then they can't actually Steelman it in an argument. It's just fucking weird. It's like some shit you do for your boyfriend if you're a chick.
If only there's a way to figure this out for yourself.
Wait, no, he did.
Geo had a fucking YouTube channel or a Rumble channel where all them fucking streams were recorded, and you can learn about this. It's a shame that doesn't exist.
Is he Steelmanning it right now, or is he just wasting my time?
Oh wait, it actually does exist.
What's with the generic lady insults
except for yourself?
What's with the non-Steelman? What's with the non-Steelman? Just emotional outlash like a chick. What's with the non-actual logical argument? The emotional chick
with the victim
actions.
complex of like, there's no way for me to learn this on my
own.
I just want to concern troll.
You're requesting
it's not a spoon. It's not a spoon fed. You can just pass me the bowl like a grown man. Yeah, you can pass me the bowl like a grown man. I don't need it to be spoon fed. But it looks like none of you can actually Steelman it.
Dude, you just want to be spoon fed. There's heaps of links. It's gone over and over again. It's all recorded.
You can't articulately Steelman it.
Dude, the last time I tried to
Frank,
did not shut the fuck up.
It's been a while since I've touched on the subject.
So you don't have what I want. So don't waste my time. Don't taunt me. Don't grandstand on me.
Here comes the airplane.
Don't waste my time.
Here comes the airplane.
Yeah.
Open wide.
If you want to call it food fiend or whatever, you can't articulately Steelman some. Okay, so you're a waste of time too. Yeah, you're a waste of time.
All right, that's enough.
You're done. You're done. Anyone who can Steelman it, I'm interested in talking to you. But if you can't Steelman it, and it's just going to be you like trying to taunt me or whatever, then really you're just a waste of my time.
Dude, you're taunting everyone else. You're projecting. You're the one taunting at the moment.
Let's go with the Steelman. Let's do the Steelman. So when you get the star over the peak, what does that give you? Do you remember? What does the angle of the star give you?
All right, Infernarigo or Nito, are you going to Steelman it right now? Infernarigo or whatever, guy at the bottom of the chat.
Man, boy, that's so. Yeah, the when you get the star, you get the timing of the angle, right? And the timing is what gives you the angle. So then you test that against, your distance to the peak, and then you're using 2 angles to deduce the third. So you're going to get 2 different predictions, and one of them is more accurate. Does that help you?
That could have been the worst Steelman of anything. Osco, did anything he say seem coherent to you?
No.
So you guys weren't paying attention.
That wasn't a Steelman. No, I was paying attention.
Let's go over it again then. The star is occluded by the peak at a certain time. The star is
Okay.
occluded by the peak at a certain time. It gives you an angle. Okay? The timing gives you the angle. And
No,
then
the
you
peak
either
gives you
know the
the
distance to the peak or you know the distance
gives
from
you
the
the
peak.
angle. The peak
I think
objectively gives you the
Hey
angle.
Noah, can you shut up while he's
No matter
explaining it?
what starry
Can you stop
background
trying
you
to?
have,
You're like
No,
Max
you will
he
always
doesn't
yesterday.
have the
want you
same
to
angle to
explain
the
it.
top
He
of that
wants to
Max
mountain.
fucking
energy.
just
You guys,
heckle
can
through it.
everybody? Noah, you're strongly asking for people to steelman it. If you want them to steelman it, could you just stay on mute while they steelman it? Because otherwise, you're just trying to debate them and shout at them. If you could
No,
steelman it, you could do it yourself.
Ignito is
You're
not
requesting
steelmanning
someone
it.
else to do it.
Okay, now you're just tone policing me. You're tone policing me because you don't like that, your friend's like argument or whatever is being trashed.
Noah, it's not about tone.
It's
Ignito
the Noah hour.
volunteered to steelman, right? And so I was
Noah has to
asking
come in and grandstand for
clarifying
the next
questions to
fucking
Ignito. That
30
is not
minutes.
me arguing. That is a clarifying question, which is necessary for communication.
I'm going to give you an old lesson my grandpa used to teach me. He'd say, "Do I have to draw you a picture?" And so I'll post you a picture in the chat.
All right,
You have to have a fair discussion. You don't need to draw a picture. You just have to talk with another man like another man. Okay, so Beasticles
It's
is
like
going to
when
steal
a baby's crying and then all the adults gather
All right,
around
guys,
and
come on.
try to appease them.
Okay. Pfinky, can you steal man it, Pfinky?
No.
All right, of course I can.
Don't worry about everybody
You
else.
can?
I got you, Noah. Don't worry.
Okay, you got me. Okay, I'm turning.
All right, check this out. It's real
I'll turn
simple.
everyone back up after this convo's over because everyone's going emotional.
Hold on. You can't turn people down when you're going to talk over them. You cannot do that.
I'm not over talking anyone. I'm just turning down because they're not contributing to the convo. So I'm not trying to listen to people taunting me. I'm trying to listen to the steel man, which Beasticles has just volunteered to give.
This is like when you can't actually solve the.
Is anyone going to let me talk?
I'm turning that guy down too.
Well, Angling Alchemist was actually steelmanning it, and you just rudely interrupted him and talked over him. That's what happened.
Are you talking about the guy at the bottom of the chat, Infonigo? I did not talk over him. I asked this clarifying question, you liar.
All right. You want to start? Oh. All right. They got you muted, but check it out, dude. It's pretty simple. All right. So, in the case of stars near the horizon, right? The 15.04 degrees per hour doesn't actually hold true because it doesn't. It apparently lingers in the sky because of refraction. And the only reason why refraction, celestial refraction that is added in is to keep the model consistent. So what we're doing is we're testing that ad hoc, basically, addition of celestial refraction to see, if it's actually justified. So what you do is you take a star that is being occulted by a mountain peak. The reason why we use mountain peaks is because the mountain peak has a fixed height that everyone can agree on, okay? It has a certain elevation, certain height, so everyone can agree that that mountain peak is this high no matter what model you're talking about, right?
Can you restart, bro, real quick? I was like coming in and out. I was trying to get so I could ask clarifying questions.
Okay. Yeah, you have a star.
So you.
Oh, you're coming in. You're kind of breaking up.
Down. Say.
You're breaking.
Am I good now?
Kind of. Let's try again.
How about now?
So it doesn't sound like you want to steelman. It sounds like you want to debate or you want to discuss it. So you do know about it.
Okay, this is.
You are breaking up a bit, Noah.
Jesse and QOP have both laid it out for me, and I've been here asking multiple times for other people to lay out, and no one's actually really volunteered until today. Infuego, Infero, Ginito, or whatever, and Beasticles are pretty much the only two flat earthers who have actually volunteered to ever steelman it for me.
You are so full of shit. I did this with you.
But let me just get this straight, dude. So there's two observers, right? There's an observer on a mountain, and then there's an observer on the ground, far away from the guy on the mountain, correct?
So when we say observer, right? Basically, there's only one real observer in reality. Okay, and that's the person actually looking at the star being occulted by the mountain. The reason why we put the observer at the mountain peak at the same exact time that star gets occulted by the mountain peak is because what we're doing is we're taking the position of the star in the sky at a certain time, right? And we're extending that triangle. Are you with me so far?
Yeah, so it is what I said, right? There's an observer on the ground, and then you jump over to where the mountain is, like
the mountain
to its coordinates, the mountain peak. Yeah, the thing that occults the actual star.
Right, because we know that
and
refraction, it doesn't matter, it doesn't matter how much refraction you want to add in or take away. It doesn't matter because there's a physical mountain peak blocking that starlight.
Yeah, I understand. I understand that so far. Okay, so you have the observer looking at the peak. The star is moving down towards the mountain. The star then moves below the mountain line, and that is when it's occulted, and you take the exact time when it's occulted.
Right.
And then, okay, go ahead.
Yeah, now here's the thing, right? You have two different angles. You have the apparent position of the star, and then you have what is called the true position of the star, or the geometric position of the star. The true position
that's based off your coordinate and the celestial sphere or whatever. So like the star should be at this angle. Yeah.
Yeah, it's the
celestial
idealized celestial sphere. Correct.
Idealized celestial. Like if you were on a globe Earth with no atmosphere, that's supposed to be how you see it on their model.
Correct. On their model, right? Which is basically, the fictitious observer at the center of Earth, right? And then off into infinity, because it doesn't matter about the distance; it's just taking an angle, right? The 3953, right, in terms of the radius, and the timing and the angle, like it's just a ratio that has to be consistent throughout. So what we're doing is we're testing that consistency. So, for example, if we have, let's use the traditional Mike's Peak or Pike's Peak from Mike's house, right? So you have 204 in terms of where the star actually is from Mike's house, or 206, something like that. And we know that
206 miles? What are you talking about?
2 degrees 6 arc minutes.
From Mike's house to the top of to what he's seeing as the peak of the mountain.
To the star. No, to the star. I'm talking about the true position of the star. So like you have Mike's house, and the true position of the star is going to be 206.
Okay, but the star is moving, and I thought the star is supposed to be occulted by the mountain.
It is, right? No, exactly. Now.
Oh, so you're saying the star, its true position is above its
below.
Can you hear me?
No, it's below. So in their
model, true position. Oh, wait. The true position is that the star is the true position is below the visual or apparent position, is what you're saying.
Correct.
In the globe model, okay. So the star is actually lifted up by, in their claimed worldview paradigm, the star is lifted up by refraction.
Correct. Okay. You got it right.
So far, we're actually Steelmanning it. Go ahead.
Yeah. Right. So the thing is, when we move the observer to the mountain peak at the exact same time, right, the true position then becomes 231 or 233 about, right? Now, the rise over run prediction, which is just basically plain trig, is 231.
Oh, wait. Step back. So you have the star gets occulted apparently, but it's even lower than the ridge of the mountain.
In their model.
If you're in their model. In their model, it's actually literally or
below the mountain
peak, right? Yeah, it's geometrically below the mountain peak. Apparently, it's at the mountain peak. You're several miles away from the mountain peak, looking at it get occulted. So now you move over to the mountain and you establish it as a new observer, new position, from what I understand. But now, instead of doing an actual observation, your second observer is actually a stellarium output, is my understanding.
Yeah, dude, and this is how crazy it is. The apparent position of the star at the mountain peak is 245, which would be way above.
Which is higher.
Yeah, exactly. So the
Yeah.
globe only
Yeah, but wait,
exists.
doesn't that make sense?
It does
Doesn't that
make
make
sense.
sense?
The globe only
Doesn't that make
exists optically.
How far is the guy from the peak of the mountain?
Okay, so basically from Mike's house to the peak of the mountain, right? You have what is called the arc length, which is 27.
That's a pretty simple question, bro. Like,
how
far is the guy's house from the? Okay, I'll go on mute. You answer it, and then I'm gonna ask more
I think it's 53 kilometers or something like that. 50 something kilometers.
So wouldn't that mean it should actually be almost a degree up? Because isn't it like a certain amount of kilometers you actually move a degree up if you move over towards the star?
Yeah. So if we're on a ball, there should be a drop over distance.
No, if you're on a ball, if you're on a ball and you move towards the star should move up, not down.
Yeah,
it does. Yep. So basically,
okay,
it
so that
raises it up.
Ball, then.
No, it doesn't. Dude, all right, check this out. Let me just try and explain it in simple terms. Okay, you have two predictions: rise over run, and then you have rise over run minus globe drop. You with me?
Globe drop.
The drop over distance between Mike's house and to the mountain peak. Okay, it's supposed to be. There's supposed to be a drop over distance, right? In their model, there's supposed to be
which would cause you to orientate and look further up, giving you a larger angle from ground to star at the farther position at the mountain's peak.
Which would give you a farther angle. I think so. I'm not sure.
If you drop down on the globe and you're reorientated, because that's at the globe, you're standing upright is not actually parallel for everyone. It's a divergent up from the center of the Earth.
Right. No, yeah.
So as you move away from the initial observer position, as you quote unquote drop according to the initial position, your uprightness would actually change 1 degree per 69 miles or 1 degree per 60 nautical miles, right? So if say the mountain was 60 nautical miles away, the star by globe math, if there was no refraction, if you're on an atmospheric Earth, the star should actually move up a degree in angle.
Yeah, if it was 60 nautical miles away, right? Now, the difference though being that what is occulting the star is actually the Earth rotating, right? And the star is getting lower in the sky because of Earth rotation. In our conception, it's getting further away, so we would expect it to linger longer. You see what I'm saying? Now, they explain that lingering effect as celestial refraction in order to keep the globe model consistent. You see what I'm saying?
Yeah, I kind of see what you're saying. Yeah, I mean, I guess I see what you're saying thus far.
Right. So, for example, to give another analogy, like when we say the sun it should have been set already, right? They will claim that the sun is actually being refracted up over the horizon, over the curve, and showing you the sun, but the sun is actually already set in terms of the true position of the sun.
Flat Earth's gonna have that as well, and I can make the argument for it.
I agree with.
Not
what
to say
you
that
said,
you have to. I'm forcing you into this view of Flat Earth.
Jesus Christ, Gate.
Go ahead.
I'm just trying to level with.
No, we're with you. I mean, I think Noah's with you as well. We're hearing you out.
Okay, yeah. So there's two different conceptions, right? So you have the star being occulted by the mountain peak because of Earth rotating, and that's what's causing the 15.04 degrees per hour decline in the sky. So like the star is declining in the sky right? So there should be a certain point, no matter what, in the globe paradigm, where you can no longer see that star because it should be occulted by even the Earth curve, by the ground, by the horizon, right?
Yeah.
Yeah, but in this case, you have a mountain, so even not just the Earth curve, you have to add the altitude of the
good
mountain.
point. Very good. This I can see you could see it in your mind. Very good.
So the thing is, right? Let's say there was no mountain peak there, then they would just basically say, well, that's just refraction, and they just basically ad hoc refraction, and then there would be no conclusion. But now, because there's an actual physical mountain peak there, now you can actually make a determination on mutual exclusivity in terms of what the stars are actually doing in the sky. And how you do that is by comparing predictions. So one prediction has the drop over distance, which it turns out to be 217. So, and then the rise over run is 231. And if we were comparing what the true position of the star would be.
Did you just quote two angles? Is that what those numbers were? Okay, so you would add those angles up?
No. So 231 would be rise over run, just plain trig. 217 would be plain trig minus drop over distance.
The rise over run is for the mountain because you're not looking at the horizon, you're looking at mountain, correct?
And how you do that is by comparing predictions. So one prediction has the drop over distance, which it turns out to be 217. So, and then the rise over run is 231. And if we were comparing what the true position of the star would be.
Did you just quote two angles? Is that what those numbers were? Okay, so you would add those angles up?
No. So 231 would be rise over run, just plain trig. 217 would be plain trig minus drop over distance.
The rise over run is for the mountain because you're not looking at the horizon, you're looking at mountain, correct?
Yeah, that's just plain
angle between how far you are from the mountain. Yeah, how far you are from the mountain. It doesn't even work because they claim that the Earth isn't like a flat baseline.
No, they claim that there's a drop over distance.
So you got 2 degrees of drop over distance from.
No.
That doesn't make sense because the guy's not even that far away from the mountain.
I don't think you're not following. Okay, from the observer in real life to the mountain peak, right? That's a right angle triangle. If you just use plain trig. On a globe, you have drop over distance to take into consideration, which would drop the angle a bit, right? It would be half of the arc length.
Yes. Okay. Yeah, I got that. So you
half
have to
of
subtract.
The arc length is 13 arc minutes. The whole arc length is 27 arc minutes.
Where'd you get
the globe?
arc length?
The mountain would be lower on the globe, right?
Yeah, the mountain would be
from
lower.
Someone else interrupting.
Yeah, Pfinky. It's all good. I think he's just asking a question. But the point is, Noah, is that no matter what, you have a specific arc length, which is from the observer to when the mountain peak is occulting the star, and that gives you an arc length, which is the celestial sphere arc length, which is 27 arc minutes.
Where'd you get the 27 from?
That's the distance. If you were to convert the distance,
did you add in the drop from the globe or whatever? Like this is the final product, including the rise over run and subtracting for the drop on the globe. That's what you're saying. It should be 13 arc minutes.
Yes. Yep.
Okay, so we're looking at the mountain. The mountain, the top of the mountain on the globe model is 13 arc minutes up, angled up.
No, lower than the rise over run. The rise over run prediction.
Oh, so the 13 arc minutes is not the whole. That's not the difference or whatever. That's
No, that is the difference.
That's the globe drop. That's the difference due to globe drop between if you're on a flat plane looking at the peak of a mountain versus a globe looking at the peak of the mountain. Okay.
You got it. Yep. Exactly. Right. So now, in terms of conceptions, we have two different conceptions. For us, we say that things appear to drop optically. It's an apparent phenomena, right? Due to optical effects, right? It's not actually because the ground is curving beneath your feet. In their conception, it's literally because the ground is curving beneath their feet.
But if there was no curve or no whatever, it would just be a straight right. If there was no curve or there was no atmospheric
drop over distance, yeah,
there's no drop over, atmospheric whatever, then the thing would actually be 13 arc minutes higher. But because they're on a globe or what we perceive as like a standard refraction type of thing, it is 13 arc minutes lower. Okay, I got you. I'm there so far.
Right. So now when we move the observer to the peak of the mountain using their model, like using their conception, right? You would expect us, in terms of the flat earthers, to be off by the amount of drop we did not account for.
Off. Okay. Yeah, I understand that. Yeah. Okay.
You see what I'm saying? But we're
like you should be on a flat baseline. You should actually be 13 arc minutes higher in reality.
Exactly.
And they should be 13 arc minutes lower in reality. Although you are visually at the same spot as them, physically you should actually be 13 arc minutes, like geometrically, compared to the first observer.
That's what we're doing. We're comparing the true geometric position of the star in order to come to a conclusion. And the globe is off by the amount of drop that is predicted every single time. Which means
how did you get to that off?
Which means
how did you get to that off?
Okay, so the true position of the star, right? The true position of the star matches the rise over run.
But where the true position of the star from the top of the mountain, not from the initial observer?
Well, for the initial observer, the true position of the star in their model, in their conception, is going to be 204 or 206. But we can't see the star in terms of its true position. Like, what they would say is that, okay, its apparent position is 217, 219, right? It's the true position is actually 204 from Mike's house to the star, and that because you're on a globe, it's actually being refracted up 15 arc minutes in order to give you the 219 or 217, depending on if you want to add in terrestrial refraction. That's the apparent angle. Like if I were to take from the angle from Mike's house to the star with its apparent position is going to be 217, 219. Just about, like, in between those. Right? And that's essentially what they are saying in terms of, like, the drop over distance. So, like, if we're going to compare,
are you wait, so you're saying that you're taking the Glober's observation from observer 1, but you're taking the flat earth observation from observer 2 on the mountain, and then you're saying the guy on the mountain is more accurate? But that's kind of like apples to oranges, is it not? Because it's two different observer points.
I don't know if you're able to, like, see a visual, but I think this would be better with a visual, because I'm trying to explain it visually. Are you driving?
Yeah, a little bit.
Okay. Let me see if I can pull up a diagram real quick, and I'll post it a screenshot, because I think it'll help with that.
Beast, do you guys predict a later occultation or earlier than the globe?
Earlier.
So the globe would be later.
No, the globe would be. I'm sorry, I said that wrong. The globe would be earlier.
So the mountain's lower in the globe, but it would block the star earlier.
It was blocked to start earlier because it should be following that decline based off of Earth rotation. The lingering effect is, that's if you can't account for if you are using refraction to account for that lingering effect by using the occultation instead of just staring at a star and taking the angle to it and just saying, oh well, it's it's being refracted about this amount because it has to fit to the globe. We're taking away that ad hoc explanation, essentially. Give me a second, though. I'm going to pull up a image here.
It just doesn't make sense that the mountain's lower and it would block something earlier.
Okay. Let's see here. Where is it?
It blocks it earlier because of the geometric cutoff. That's why you would predict that the globe should cut off earlier.
Yep. There we go. Central angle theorem.
Think of a car driving away from you on a dead flat level surface very far until you can't see the lights anymore, versus a car driving over a mountain.
Here we
Once
go.
it crests the peak and passes over the peak, it's gone.
All right, so I posted the image here. Posted the image here.
All right, I see the image.
Okay.
This is like the official
this is a
image
great
for you guys.
Yeah. This
Okay, I'm saving it
incorporates
then to
all
my
of it.
phone. Okay,
Yeah,
great.
save it so you can understand it. Because it's this one right here is basically the Steelman. So you have the observer, which is see where it says the distance FE model versus the distance globe Earth model, right? And then the central angle. Now, the central angle is going to be the same in terms of the arc length for both models.
Yo, this is a great ass diagram. This fucking diagram is so fire.
It is. It really is. It helps. It helped
This
me
is
a
on
lot.
this could honestly, this makes up for like the 3 guys who were like crying like babies earlier. This actually makes up for everything.
I got you, bro. I got you. This isn't very important though, because there's a certain arc length to to the observation. So like no matter what observation you're making, like how there's like over 50 now. Basically, there is a certain distance, which is the arc length that is finite, right? Like between the observer and where the star is being occulted, you're gonna have an arc length, right? In both conceptions, right? Whether it be the stars are basically whether it be like the ground is curving and the sky is flat versus the ground is flat and the sky is curving, essentially, because in their model that's how they treat the sky. Essentially, they treat it as infinite flat space because it's so far away. That's what the celestial sphere is. A celestial sphere is with infinite radius. An infinite radius is basically flat. So they treat the ground as curving, and that the stars is the star field is flat, versus our conception, which is flat, and the stars are curving essentially. Optically, this is all optically. I'm saying.
So wait, are you comparing the first observer position to the second observer position and then saying like GE only has the first observer and then FE has the second observer and then
no,
because that doesn't if it's
no,
different, if it's observations from 2 different points, how can you compare the two?
No, we're comparing what's important is that we're comparing the true position of the star. Period. On both models. Right? There's only one true position of the star that compores with 15.04 degrees per hour.
Here's the part that I don't understand is in the diagram, how is the star not at the same angle?
What do you mean?
Like no matter which model you're on, when you go out there and look at the star being occulted, they'd be at the same location, no?
Yeah, in reality, we're just looking at a star, like whatever you want to interpret it as, but only one model is claiming drop over distance, that the ground is curving beneath.
Yeah, but I'm saying when you're looking at that star, that's already factored in for the Glover. You don't do it after the fact and then drop the star on a diagram. You keep the star in the same spot.
No, exactly. That's exactly the point of it, because when we move the observer from where the observer actually was to the top of the mountain peak to compare, the internal consistency of the globe model, we find that the true position of the star compores with rise over run, which means that the drop over distance is only an apparent phenomena. There's no actual drop over distance. It's just apparent. That's the important part of it.
But wouldn't changing to Noah's point, wouldn't changing your location completely affect the apparent position? So why would you change to the top?
The apparent position goes to 245. But we know that's not the case because we can't see the star no longer. And the mountain, right? The mountain peak, the rise over run prediction, just plain trig, is going to be 231. So if it's higher than that, then you should still be able to see the star.
That's why they call it an external reference instead of always appealing to apparent. What's apparent? It's not. When you use an external reference, it becomes physical.
Exactly.
And that's why you'll hear Jesse constantly go back to apparent. Well, what angle are you looking at it through the theodolite when you're looking at the peak? Ignore the fictitious observer because that's apparent. It eliminates this external reference.
That's a great freaking Yep, exactly. They can't deal with the true geometric position of the star because it completely shows that the conception itself of the celestial sphere and its internal consistency of 15.04 degrees per hour is literally just an idealized model, and that celestial refraction is incorporated in order to keep the internal consistency valid in order to be useful for celestial navigation. Which is why you can't use stars that are below 15 degrees on the, towards the horizon, or 70 plus degrees near the, near a zenith, near 90, because it's.
So wait, which two numbers are you comparing on this chart you gave me? Because it would be two angles. So you're looking at theta. No, it wouldn't even be theta, because theta is the actual position. No, wait. You would be you'd be comparing theta with phi. That right?
I wish I could read Greek more so, but essentially
theta is the circle with the horizontal line through the middle. Phi is the circle with the vertical line through the middle. But from what I'm looking at this chart, you would be comparing theta with phi. If I'm correct,
so,
like you have to be okay. Go ahead.
Yeah. So you see how is that beta? I'm not sure if that's beta. The B. How do you say that one?
Yeah, that's beta. That's beta. If it looks like a capital B, it's beta.
So observer true star peak angle, and then peak true star angle, right? The observer true star peak angle would be theta equals beta minus 90. You see how it shows where beta is right there? Which is basically just flat. That's just, you know.
Beta is just 90 degrees plus theta, it looks like to me.
Essentially, yeah, exactly.
So beta doesn't really matter. It's just pretty much theta.
It's just in there.
What matters.
Yeah.
Yeah. But theta would be
it's basically two models. So you see the gamma on both
I just picked up
of
my
them.
chick.
That's okay. Do you see where the gamma is supposed to be for the globe? How it's comparing it to the central angle with the fictitious observer at the center of the Earth? Basically two models. So you see the gamma on both of them.
Chick.
That's okay. Do you see where the gamma is supposed to be for the globe? How it's comparing it to the central angle with the fictitious observer at the center of the Earth?
Yeah, gamma is the difference between theta and phi, like I said earlier.
Right.
So gamma is the thing you're looking for.
Right. And do you see how there's two different gammas?
There's a pink gamma and there's a green gamma.
Well, they're both green, but
No,
but
there's
yeah.
a pink
you
one.
mean the yeah. There's a half gamma, then there's full gamma. The full gamma is the arc length I was telling you about.
Yeah,
the 27.
So 26, and then the half one is 13, correct?
Yeah. Yep. Exactly. The half gamma is basically the drop over distance. That's the globe drop. It even says it right there. Half gamma equals globe drop.
Yeah, I'm seeing that.
Right.
Yeah.
So, when we go the full arc length, and what I mean by go the full arc length, we move the observer to the mountain peak. We're traversing the entire arc length, the full gamma. When we do that, we recover the drop over distance because the true position of the star matches the rise over run prediction. So where's the drop over distance? It's non-existent. Doesn't exist.
So here's another confusion I'm having. Why, when the star is occulted, how does that factor out refraction?
Because it's a timing thing.
Yeah, but in my mind, the star's curved path would still affect when it gets occulted.
What do you mean the star's curved path?
Right, the path that the light is taking to reach your eyes, its path will affect when that gets occulted, right? Whether it's curved or straight.
True.
Okay, so it's occulted, right? For it doesn't matter, whatever conception, whether you're a flat earther or a globe earther, the star's occulted. Okay, how much refraction? How much is that star refracting?
Included?
When you can't see it.
When you can't, you're making that's a separate argument, right? You're saying
you can't see it, so you don't know how much it's refracting. That's the point.
You don't know how much it's refracting. Well, I don't think that makes sense even for your worldview, right? If you're claiming to get the true position, right, then you would know how much it's refracting to the mountain peak, because you know where the star's at and you know where the mountain peak's at.
We have it in the spreadsheet where you see the amount of refraction at that angle, at that timing for that star, right?
For the flat?
Let's no, for globe.
So I think he was relating to the flat.
Well, the flat is so minimal.
Well, we said for either model, it doesn't matter because we know the refraction's there.
Right. But the point is, though, if you add in the amount of celestial refraction that is incorporated. And by the way, all of these celestial refraction coefficients that are used at those very, very low angles towards the horizon, there's no variable, like actual physical variable, like temperature, pressure, humidity, incorporated in it. It's literally just a curve fit formula to keep the model consistent.
I got a question. Does the FE version have straight paths of light to the stars or curved, which would mean refraction?
Well, we can consider terrestrial refraction or even temperature, right? In terms of like, okay, certain temperatures would give you a difference, plus or minus a couple arc minutes, but you're still talking about like 13 arc minutes in terms of difference. So that's enough to determine which model actually is closer to reality.
I hear you, but does the FE one, is it using straight paths of light, like from the stars, or is it like curved?
Just angles, you're just taking angles to stars, essentially. But as soon as you can't see the star anymore, right?
Well, hold on. So it's literally, it's just straight paths of light, not assuming refraction, not curving it?
Yeah, no, it's just when you can't see the star, and then the true, like, so no matter what, right? No matter what, we're granting the idea that you can get the true position of a star in general. Okay? The true position of a star all comes from the first point of Aries.
Bro, so, we don't need to sugarcoat it. Okay, so the flat Earth one.
I'm not sugarcoating it, dude. I'm explaining it.
So the flat Earth one is using straight paths of light to the stars. So all these contentions and hard times we're giving to the Globers is because they're trying to fucking look through a variably refracted fucking medium that changes, and it's hard to be precise and specific. But conveniently, the flat Earth side here is just using straight paths of light and saying that's where it actually is, and forget refraction. That's just a Glober problem. Forget light bending and curved paths of light. That's just a Glober problem.
It's testing the internal consistency of the model, basically, of the celestial sphere and this timing.
No, dude, it's not fair. There's
Yo,
unfair
Beast,
standards.
I gotta go. I'm with my chick right now, but I would actually like to pick this up with you specifically.
I got you, bro.
You seem to be the guy who's actually qualified on the thing. Maybe even we can make an event here at this server where we can fully go through it. But
I'll just talk to you in private, bro. It's way easier that way.
Yeah, or we can go down to VC2 at some. Actually, VC2 probably be the best bet at some point. But I'll hit you up when I'm back on Discord. Like if I see you in the thing, I'll hit you up and we can go to VC2, something like that.
Just DM me for sure.
Yeah, and we could even have a different separate live stream bot or whatever. However the server
I can even record it if you
up.
want. If you want to like show it, in case other people have questions.
Yeah, I mean for my own edification.
How is it fair that?
But I'll get you later, Beast. Thank you so much, Beast. Thank you for being a guy who doesn't waste my fucking time.
All right.
How is this thing fair if the Globers have to worry about this real phenomena that's happening, but the flat Earth side is just not like, apparently light doesn't bend through a medium, and
light's
when we're
not fair,
looking
gatebreaker, sorry,
and we're looking at stars, that thing is, we don't know how far it is. It's not as far as the Glober model, but it's some far distance away, and it's reaching our eye in a straight path of line. No, there's just no fucking medium it's going through. It's not bending, it's not curving. That's and somehow using that
let me ask you
line of thought. Using that line of thought, we've devised a method. Like that line of thought, like reality light bends. So how could this be a test of reality?
Hey, when you take an angle to a star, what is that?
How could this be a test of reality if the flat Earth side is not bending their paths of fucking light? That doesn't make any sense.
Hello? When you take an angle to a star, what is that, dude?
I'm no longer engaging you, dude. Like I tried multiple times. Like you don't even want
to address it. Okay.
Yeah. So I actually brought up a point and brought up a claim. So
It immediately addressed your point.
But it's okay. There's no explanation needed. This is what is happening. It seems that the flat Earth, whatever, is assuming straight paths of light. This is not what is actually happening in reality. It's an idealization at best. It's okay. Idealizations have its purpose. Globers do it all the time. But this can't be a like 100% true. We're just so freaking accurate, down to the crossing of the mountain while still using straight paths of light. Like that changes everything. If that path of light is straight and it's crossing the mountain, if you start curving it, its position, its literal position, its intersection point will shift. So like, I'm not saying flat Earth can't work or this breaks flat Earth. I'm just saying this is something to consider. But since I've delivered that, I appreciate that. Thank you very much. Go ahead.
Yeah, you're acting as if they're bending it though. The people taking the times and then looking at the recorded data afterward are just documenting what is there. If it doesn't bend, it doesn't bend. It's not like they're removing something that exists in order to make it look flat. They're just recording data, looking at the data, and the data doesn't match the predictions for the globe.
Yeah, exactly.
To
Dude,
that
Moto
point-
popped. Way to Steelman, dude. Thank you.
To that point, I wanted to ask you about my first question again, Beast, which is maybe I'm not understanding the diagram, but
you know what, Anchovy, I gotta go too. But when Noah messaged me, I'll DM you as well, so you can come in there. Okay, I got you.
All right, peace out, dude.
Yeah, that might be better because I have to rush. And I don't want to rush this, but dude, it took Alan a year to like fully grasp what Dr. Mike put forth. Just so you know that, right? And then by him understanding it, it helped me understand it because I'd like to break down this entire, I like to break it down in layman terms so I can understand it, and by doing that, other people understand it. So it's been a lot, but once you understand truly what central angle theorem is, it kind of really highlights the difference between both predictions.
Yeah, never mind. If you gotta go, then I don't want to keep asking questions.
Yeah, it's all good.
I think not having Alan's vocabulary helps describe it to people. Like that's my position. To be honest, because I've listened to all of the updates and I can conceptualize it in my mind because I'm a mechanic by nature. Like just putting physical things together, I've built a lot of things from scratch that I can see the end product before I start it. So when I hear what he's saying, I get to pause and look up vocabulary, then I can conceptualize an image in my head, but I can't repeat his vocabulary because I'm not reading like he's reading. So then I just put it into layman's terms, like you said, Beast. And I think it's more relatable.
So in your opinion,
some weird stuff. I never even knew about any of this stuff until trying to understand the cell Theo, because I wanted to know why Dr. Mike, says like, dude, this made me a flat earther. The dude worked on satellites his whole life and was a glober. You know what I mean? So like, I wanted to understand how he got there. And I wasn't too familiar with stellarium and azimuth and right ascension, declination, all these terms. Like, you have to be familiar with all these things.
The way I'm hearing the arguments laid out is that the globe prediction is off, right?
The drop over distance is just assumed. Essentially, that's essentially the bottom line.
What about the negative angle, though? I mean,
then we have the same argument. Yeah. Okay. I've had that problem
what
with
about the negative angle, though, Beast?
What'd you say, Jeremy?
What about the negative angle?
What about it?
I mean, you said the drop like isn't there, but like when you do this and you get a negative angle, that would be some drop, right?
But like, what do you mean negative angle?
The negative angle when you get the star occlusion below horizontal.
I mean, you still have two
You
different
remember
predictions.
the big blowout we had over that?
Yeah, you still have two different predictions.
Yeah, but to say like the drop's not there, like you got a negative angle, so.
Well, yeah, but it's not the ground curving.
Yeah, but you're trying to do these observations and say that there's no drop. Like it's optically, it looks like it's dropping a little bit, right?
Well, that's our premise is that the drop over distance is literally just an apparent phenomenon. They're the ones that say it's a physical attribute of Earth. I mean, wouldn't both be true in the globe model? What? That it's both physical and optical stuff going on? Well, I mean, yeah, of course. I mean, in both models, yeah, there's physical and optical phenomena, but there's only one that claims a drop over distance in terms of physical. But like the optical phenomena in terms of like bendy light, for example, the only reason why celestial refraction is incorporated to that extent at those angles is to keep the model consistent, is to keep that timing intact, because time in their model equals an angle. Okay, so where I'm ending up is you guys are saying the prediction isn't wrong, the math to get to the prediction is wrong, right? Because if you're a glober and you go out to predict where a star is, the globers seem pretty accurate to know where they are, right? Two observers go out, they're going to both know where the star is.
Hold on. There's a thing that people often miss about those observers, which makes it more funny why they want to cry about using a peak for a crosshair, quote unquote fictitious observer. From all of the globe's measurements, the observer is at the center of the Earth. So every single thing they start with is a fictitious observer, but then they cry when you utilize a fictitious observer here to create an external reference.
I mean, if you ask me, I don't know why we're using fictitious in either model. I don't know why we're jumping to a mountain peak.
You're actually not using it on the flat Earth model. All you're doing is using the mountain as a crosshair. Think of it as like a mile-long telescope.
Yeah.
Well, not if you're moving the observer to the mountain peak. You are changing his view, no?
You don't actually move the observer to the peak. You're just assuming you're predicting what the angle to the star would be from the theodolite location, and then if there was a person with a theodolite on top of the peak of the mountain, and then you're seeing if it lines up all the way through when the occlusion happens. So when they say what you just said, they're just trying to make it sound bad.
Well, because in my mind, how do you know the angle from the mountain peak if you're not up there doing it?
From their own software.
It's their own. That's the point, dude. It's you're testing the consistency of the model externally, right? The external part is using the mountain peak because that's like connecting the stars with the actual ground. Like, let's say there's no mountain peak, Anchovy, and I gotta go after this, but let's just say there is no mountain peak. Then the lingering star that's in the sky longer than it's supposed to be, because we're supposed to be rotating and that star is supposed to be falling below the curve, essentially, right? They would just say, oh, well, it's just being refracted up by this amount because this is the amount that it's off by.
Because refraction exists in that model. They understand that, so they're accounting for it.
But they're not. There's no actual justification for it. It's just to make it work.
You really think that? You really think there is no justification for
There's no justification
accounting?
for it. No.
Excuse me, I didn't finish my question.
You said
Do you
really
really
think
not think there is justification for incorporating refraction in their model, which ought to
celestial
exist?
refraction? No. Yeah, there is none. If you actually look at celestial refraction, they treat the Atmos as an idealized sphere of concentric layers.
Dude, there's something going on with you. You're not getting the point. Why are you blocked off to the
you're
fact?
just retarded. And
Why are you blocked off to that? I just figured this out today, so don't think that I've been cooking this up. Why are you blocked off to the fact that there's a problem with the flat Earth side just using straight paths of light? I don't care I don't care what the globe does for anything. We're looking at the flat Earth right now. Why is there straight paths of light for the stars through a medium?
They're not using straight paths of light or changing bendy paths of light. They're just observing. And if it comes up straight, then it is.
Moto, per Beasticles,
Hey,
correct me if I'm wrong.
You asked not to be interrupted, right? And you just
bro, we need
interrupted him.
accountability.
Shut the
You
front
guys.
door.
Okay, hey, have
Shut
fun
the
with
front
it.
door, dude.
Have fun with it.
He's
Hey,
trying to
I'm gonna
explain it to
spread
you.
the word though.
What is with America
people
and
should
generating
know
these personalities?
that the flat Earth side is using straight paths of light. That's
absolute
not
interrogation,
good.
man.
You ask a
I don't
question
understand
and,
why you
and
think-
interrupt the answer,
Yeah.
bro. It's fucking retarded.
Yeah. We've
People
had
on
two of these
deafen.
clowns so far. I don't know what's
For-
going on
for
with
other
America.
people.
Something's in the hot dogs.
Thank you, Moto, by the way. Appreciate it, bro. I'm glad someone else understands it, too.
No, you too, Beast. I appreciate it. Yeah,
Hey,
for other
hey,
people,
Beast.
though, they're not using a certain
and you
type
too,
of
Colin.
path
I'm
of light.
sorry.
No, I was
They're
gonna say,
just
dude, would an appropriate answer for that question be that the timing gives you the angle, and that's what gives you your straight line? Because it's just the time you actually observe the star.
Yeah.
Well, that's where I get confused about the diagram,
I gotta
right?
go,
If a
though.
glober, if a glober and a flat earther go out to observe this star being occluded, it will be at the same spot. So why in the diagram is it always in a different spot? I don't understand that.
prediction versus reality.
Yeah, I think they
You-
need the refraction. They need a
So-
fudge somewhere to put the globe in there.
I don't think you guys are grasping what I'm saying. Like if a glober was to predict where a star is, are you telling me he'll be wrong every time until he steps outside?
That's a good question for why can you turn refraction off in stellarium?
Yeah, they're wrong when you utilize an external reference. They're correct every time when all you do is look at the apparent position.
So all the globe Earth astronomers are usually wrong when they're trying to guess where a star is.
No, they're using the apparent position only, not an external reference. That's not the method.
Well, that's why I made the point that in the Glober model, they would account for both, right? You can only predict where something apparently is. Where you see it is what you're trying to predict.
Until you add an external reference. That's why that they've had a update on this every week for a year, minus weeks. That's why there's so many updates on this, because it's like
Your external reference, though, you guys told me was a program, a Glober program that they use to predict where the stars are.
No. It's a physical obstruction.
Well, if you're referring to the mountaintop, if you're referring to the mountaintop, again, the Glober would see the same mountaintop that the flat earther would. That's why it confuses me.
You
I got
have
a picture
multiple
for you.
predictions. You're mixed up there.
Yeah. And besides, man, no one really disputes the locations of the stars and their GPs. That's all when they're referring to that program. It's just managing and handling that, the GP location.
Yeah, I'm not even arguing for a side here. I just get lost in the translation, I guess, because on one hand, you guys are turning refraction off, but then arguing for apparent position when, in my mind, refraction on supports apparent position more than anything.
No, they're arguing for a true position.
Yeah, I think the part of the reason why, I mean, correct me if I'm wrong in this, and I've tried to explain this sort of stuff, but I mean, you need actually a non-refractive observation or like measurement, sorry, in order to compare what's going on with the refraction. You can't use two refractive, formulas or results because you won't know what the refraction's doing.
Well, Rick, isn't one of the core like FE arguments is telling the Globers, oh, you don't know what's out there. You're not actually going out there. You don't know where things are. Things are apparent, but then we get into this self-Theo argument, and all of a sudden you guys know the quote unquote true position. I don't understand. It's like arguing for both simultaneously.
It's the GP position, man.
Yeah, it's actually a method that happened. I forget exactly when. I don't know if it was the 1700s, 1600s, or something a while ago. One of the episodes has it on it that they found this research from someone else from way back when, but it got buried. And so essentially, aside from that, it's a new method, and that's why you're confused because you're just stuck on the old argument and the old method.
I think
I'm not even aware of an old argument. I haven't heard of any of this until you guys started bringing it up. I'm just thinking about it as you guys explain it to me.
Yeah. So big problem is the assumed straight paths of light, which is I'm not going to get into it, but that's number one. At a deeper level, at a model framework level, the map being used, basically the stars that we observe over our head in any model. How can I explain it to you guys without you guys? I predict the flat Earth distances for all of this stuff is as far as the ground goes is using Glober distances. If you imagine the globe, a ball in your mind, okay, and then outside of that, somewhere farther away, you have another ball, and you plot like the stars in a simple manner around them. That's not how they actually work, but this is a simple idea of a celestial sphere. You've got one ball, and then you've got another ball. If you rotate both of these balls, their rotation rate corresponds to each other. Is anybody following me? Because I'm hearing people dropping. I might be in the wrong place and time for this.
Yeah, dude, you're losing the crowd right now. You got to get it.
Okay. All right. You guys can carry forward.
It's not necessarily you. It's just a place and time for every delivery.
That's
Gate breaker. Look, if you have train tracks that look like they're converging and touching in the distance.
I know that shit, bro. I know that stuff.
I know, but it's the same thing. Look, if you go and actually measure it, and you get a measurement of it, and you find out that they're parallel and straight and they're not touching, you didn't just take a bending train track and straighten it. That's exactly what this is. They're saying that the light's bending more than it is. It does bend, but they're saying that it bends more than it is. When you take an external reference, which is a measurement of it, and then it comes out to be straighter than what you expected.
That's not what I'm talking.
Flat earthers straightening a light. Yeah, you're saying they're straightening lights.
No. I mean, no. So, in order to kind of predict model-wise to understand what's happening, you have to have the star field. You have to have an origination point where the star actually is. And this method is using the Gleason map with a star plane overhead, assuming there's some one-to-one celestial sphere matching to the globe. It's not. The ground distances between a flat plane and a globe are not equal in any way, shape, or form anywhere. So for the globers to do 69 degrees per mile, I bet you they're using that in their flat Earth. There is no 69 degrees per mile in flat Earth.
Why not?
Because think like the Gleason map, the southern hemisphere. You know how it's like the distances, at least as they appear, they're massively warped.
Isn't it in relation to the stars in the sky?
Well, the stars in the sky aren't warped like that. They appear as they appear. It's only that Gleason map that warps fucking Antarctica, or excuse me, southern hemisphere. The stars are up in our sky. That's not warping. It's one. Okay, if I could see Australia up in the sky above my head, and one model has it warped, I could compare it to what I see above my head. I'm gonna be like, what I see above my head doesn't look like that. So, but we're doing that with the stars. We can confirm what's above our head.
This is a wild roller coaster, man.
Yeah, so 69 degrees per mile doesn't work on flat Earth anywhere because it's not actually 69 degrees per mile. The stars and the ground, they don't correlate. It's not. That's like a I don't know if it's linear. It's like a everywhere on the globe is that. That's not how it works on flat Earth. Okay, so that's another one. There's just this is all wrong.
It's definitely 60 degrees per mile.
That's
on the flat Earth. Yeah, 69 degrees per mile on flat Earth. That's exactly what it is.
But that can't work. Because distance
well, it can't work on a globe either. It would have to be 1 degree per 69
No, you have to address the fact that it doesn't work on FE, and at least for the Gleason one, as we're speaking about.
Well, you have to say it right. You have to say it's 1 degree per 69 mile.
That doesn't exist on flat Earth. It changes based on where you are on the map.
Yeah, but you said it was 69 for 1 mile.
It changes for the globe with refraction. You can only do the 1/69 when it's right above you. There's no difference here. You can't do it at the horizon.
Don't bring up but what about? Let's accept the point, understand it, and then we can move on from it. I'm not doing this half-crap work done bullshit. Okay.
No, I'm trying to dude. The whole point of this observation is a comparison. It's all about what about the flat Earth and what about the globe? What predictions do they make? It's all about that.
From the flat Earth side, the whole thing is bunk. It's loaded with assumptions.
You're just
loaded
that
with
shit.
Glober math, loaded framework-wise, using balls where balls don't exist, and then assuming there's some kind of like 1-to-1 or it's the same, or we're using the celestial sphere as if like a sphere and flat, like there is any kind of anything going on. It's not. It's all fucked. Curved paths of light that are actually curved because they're going through a medium is being misrepresented as straight lines conveniently. We're assuming all kinds of globe everything, celestial sphere, distances, the proportional relationship between distances and degrees that the glober has, thanks to its geometry that flat Earth doesn't have. It has a different one. It just doesn't have that one. So we can't use that one.
Relationship. It's a symbiotic relationship on both sides. The globe needs a flat plane in order to operate, and a flat plane needs a sphere to operate. You need your celestial sphere. It's just hand in hand. There's no figuring it out.
You could think it's either one and be right. Yeah.
Yeah, if I hear Jesse or Ruhip say what Gatebreaker's saying, it sounds like they're lying and being disingenuous and they understand both sides of the argument. When I hear Gatebreaker say it, it sounds like he's reiterating what he's heard from other people.
Speak for yourself, bud. Man up, speak for yourself. If you think one of your peers are shill, speak for yourself. Don't do this weasel snake game through other people. Speak for yourself. Go on, bud. Let's speak again.
If you're going to Steelman the globe, though, you got to get it right. It's 1 degree per 69 miles, not 69 degrees per 1 mile.
Well, listen, let's create some space for people who want to ask questions, because if you just all out disagree off the rip, then there's nothing to talk about.
I'm literally seeing this whole thing from a bird's
sounds
eye
like
view.
preaching.
I explained the biggest problems for you guys there from the flat Earth's point of view for your consideration. I don't think the world's flat. I'm open with that, and I'm not against flat Earth. I'm just sharing what I see and consider it or don't. So that's it.
God's eye view and both.
You're full of shit.
You just run around causing cortisol releases all over the place. Like, the fuck?
He just told us that you see things from God's perspective.
So, here's my issue. We use the mountaintop, right? Because
Both sides know the height of that.
Yes.
It's a fallacy.
So
It's an if
why?
therefore fallacy. If you have an angle to a mountaintop where a star is occluded, then you can freeze frame that in time and go anywhere else and check the angles to the stars to see if they match. And if you go there and those stars match, therefore my model is correct.
Sorry, what were you saying, Anchovy?
Okay, well let me ask them some questions. If for the FE side, why, if we know where the occlusion happens and the height of the mountain, why in the diagrams is the angle different? It seems like they're backwards deriving what we know is concrete. They're using the assumptive stuff of curvature and light bending, and then backwards deriving what we should know instead of starting what we should know and then backwards deriving the other stuff. Right? So the mountaintop and the star occlusion, the angle to the star, we should know that. But in the diagrams, it's always two different angles.
One for the globe and one for FE, you mean?
Yes. But do you understand what I'm saying, Rick? If a glober and a flat earther go out to get the angle, right? If they're the person in that diagram getting the angle to the top of the mountain peak for the angle of the star, those should be the same. That should be concrete. We should both be seeing the same star being occluded by the same mountain peak at the same angle.
They should be the same now. What do you like? I don't get what's going on here. Like in their
Even though
model,
two different
the
people
mountain
have
is
two different
lifted up.
beliefs,
One
he's saying
second,
even though
dude.
you've got
Shut the
two
front
people out
door.
there, even though two
Dude.
people are out there making a measurement and they may believe in two different models, they're both seeing the same exact thing. They're just interpreting the information differently. That's all he's saying.
Okay, bro.
Right.
So the mountain is being lifted up in their model, right? Optically lifted up.
Okay.
Cool. That's
What
how
is that?
they
That
get
doesn't
around
really.
this idea of like the mountain is, what are they? It should be a little bit lower or something on the globe. But you're saying that they're seeing the same thing. Is this the thrust of what you're getting at?
Yeah, I'm saying essentially what he just said, which is if two observers, right, a glober and a flat earther, go out to take that angle, regardless of what's causing you to see what you're seeing, your angle should be the same, correct?
Your angle will be the same. Yeah, I don't understand why that is. I mean, that's a given.
Well, that's
the
crucial to me.
rationale for the glober is because they'll say, well, actually, that mountain is a little bit lower, but the light is refracting it up into your field of view. It shouldn't be viewable on the globe, but the reason they say it's viewable is because they incur refraction. On the flat Earth, you're just making an observation, direct line of sight. You don't quite know what the refraction is doing, but we agree that we can see it.
Yeah, I'm aware. I'm saying regardless of the reason. I'm not concerned with the reason right now. I'm just saying the angle should be the same.
Yeah, this is like almost a redundant question. I don't understand why we're prosecuting
Well,
it so much.
because I'm trying to relate it to the diagrams, right? If both sides know that is a concrete factor, the angle to the mountain and to the star, why is it in the diagram that the angle is changed? If that's the only concrete fact we have, right? The claim is that nobody's measured Earth curve. So if everything else is subjective, light curving, Earth curving, why in the diagram is the only concrete fact we have always different for both sides? It doesn't make sense to me.
Isn't that the thing we're trying to test? That concrete fact that you're referring to? That's the thing that's trying to be tested. You can't
No,
infer it.
what's being tested is the Earth curvature, I
There's
thought.
two different angles because one of them's the actual measured, and then the other one's what the globe would predict.
I think he's comparing the models, the globe versus the flat Earth, in the
yes, in the diagrams.
Yeah, but I mean, is it what is this?
Right,
I mean,
but
look,
one of them is showing what the globe would predict, and then the other one's the actual measurement they got.
Yeah. So again, if that's the statement, I fall back to my other question, which is that if a glober makes a star prediction, are we saying that globers are wrong most of the time, and then they go out and see something different?
Wait, what do you mean star prediction? Like when the sun is going to
Like,
rise or something?
like where it's at? Yeah.
Yeah, they're off by, but they can only be within 4 minutes for the sunrise. Accurate up to 4 minutes.
Right, that's why on eclipses, their path to totality is constantly changing and being updated in live time as it's happening. They'll say this is where you're going to have 100% totality, but then as the eclipses or the path to totality is passing over the Earth and they're tracking it, they start making adjustments and saying, oh, well, it's going to be shifted a little bit.
Yeah,
And
all
so
that's
the
done
argument,
as a post dictation. You know what I mean? That's because we've seen it happen so many times that we can predict it now. It's not anything else than that.
yeah. Okay, well, for me, that's not a problem because the accuracy, right, is, I mean, the margin of error is small enough to where I could say that's fine because the Earth curve model is already it's not accurate anyways, right? It's all what's the right word here? Averages. You know, it's not like they at Pike's Peak they took a measurement of Earth curve and then none of this is measured as they do it. Is the argument that the FE side is more accurate than that?
Yeah, that's Alan's stance and Appy's stance.
Yeah, Alan puts forward that, yeah, and Shane.
The star lingers in the sky for too long, essentially.
Right,
Yeah,
it doesn't
I don't.
continue the 15 degree per hour shift. It's like why they tell people not to make observations below 30 degrees because of this phenomenon right here. The stars don't carry and continue that 15 degree per hour shift. What they do is once they get to the horizon, they slow down and seemingly don't converge. And they just kind of drift and sit there. Go ahead.
Which is kind of crazy to think if flat earthers are telling you that thing is just moving away from you, that's what you would expect.
Exactly.
Yeah, all of these arguments make sense to me. I don't see how they address what we see in reality being different on these diagrams, right? Like if a glober really wanted to test this, right, they would go out, do the same test. Your diagram should look exactly the same. That's my problem. So it's not a problem with what's going on in reality. It's a problem with the glober math, right?
Well, not necessarily, because if you look at the other side of the argument, like Jesse's perspective and a couple others, that they're not necessarily getting all the right data and they're kind of picking and choosing, and some of the observations are matching the globe just as well.
All the right data. I'm just specifically referring to the angle to the mountaintop and star. Those two should be the same, dead on. Every is faulty. We seem to be backwards deriving the angle when the angle is the only thing we're observing when we're out there in the field doing the test. That makes no sense to me. We're using assumptive math to tell us what we should be seeing when we should be starting from what we're seeing to get the math. It's completely backwards.
Perfect. This isn't accusing anyone or saying anyone's bad. This is just something to consider. We could be wrong at this point for all we know. You're just having a conversation. No one's belief system's on the line if anything happens one way or other.
This is that same thing of that if Q or if P therefore Q, Q therefore P type shit. But it's on both sides. If I go out and I observe something that I think matches my model, then it affirms my model.
Well, I mean, you would. I think it's Occam's razor at the final entry point of this. So essentially, because the globe's prediction is so far off, and the flat Earth, according to their math, which I'll admit I have not verified. I wouldn't even know how to verify it properly, but I've looked at it. What would it be? I mean, basically, yeah, flat Earth is closer. Globe is inferring celestial refraction. Basically, they're trying to imply that there's extra gas up there, which is causing the star to linger, and the curved path of it seeing beyond its geometric occlusion. So,
but that's a slippery slope to use this as your claim, because then you're doing what you say Globers do, and you're making math your reality. You're making this like mathematical model, and these numbers, what you claim to be true.
This is just another piece of evidence in the plot, man. Like, ain't no one staking a claim based on this purely. I mean, I'm certainly not, but other people might like to. You seem to be inferring that this is make or break or something for the. This is like Jaren, who saw the 24-hour sun in the south and then basically forgot how many sort of fake actonauts he's caught online, or through the videos that they produce. Just forgot about that part, apparently.
We're focusing on the conversation. Try not to get emotional.
Did what I say made sense to you, Rick?
Could you recap?
Essentially that, if whether you're a globe or a flat earther, the way to start to sell Theo would be to go out there and take an observation, and your observation should be the concrete stuff you're working off of. Right.
You're doing that when you look at the occlusion time.
When you look at the occlusion time.
Are you not?
Well, yeah, that's my point. If a glober and a flat earther go out, they should get the same angle.
They do.
Okay, so where in the process being that the angle is different.
For me, sorry.
Oh, sorry.
You broke up during that. Can you say it again?
Am I coming in?
That's a bit clearer.
Yeah, you're good.
Okay, sorry, I'm in a bad area. Where in the process does it end up being that the diagrams, when we look at them, the angle is different?
Is the angles because I know the globe has a geometric and an apparent one. Like which ones are different specifically, if you know?
Well, there's been a couple posted in the chat as we've been talking about it. I think the most recent one is who was it? Infrognito? I forget where it's at.
Oh, yeah,
somewhere
I see
in the
it.
chat.
I'll post it.
But essentially, yeah, so you look at that one he just reposted. Why are the angles different if both would observe the same angle? That's what I'm confused about.
They would have to.
They're not both physical angles. One of them's a geometric model. It's the expectation of what you would see on the globe. And then the other one is the matched observed reality. And they agree sometimes the observed one doesn't match the geometric expectation. So that's why you have the inference of refraction and other things to accommodate that.
So I've got the share screen up, and if you want to go, is this the diagram you're talking about?
Yo, I just got background. I just heard you say that. Let me go turn that on the live stream if you're gonna share your screen. All right, I got it up.
Oh, this is just the
So
anchovy.
if you
It's very hard
if
to
a
sort of
glober wouldn't,
go ahead.
sorry, I was just gonna say, so if a glober were to go out and do this test, they would essentially be faced with the fact that their prediction would not match what they're seeing.
Correct.
No, they just infer the refraction resolves the problem for the dip.
Right, but no, his
They
answer is
lift it.
still yes. His answer is
They
yes
lift it up.
first, and then to resolve that problem, that's when refraction is introduced. Not necessarily. I mean, if you say it like that, it seems like a tactic, but asking it over, it's just a step in the process.
In a hypothetical reality where Earth were to be a globe with an atmosphere and all the other things we learned in science, but just the globe part, light would bend through a medium, and they would need to do this in part of their modeling or whatever we call this. They would need to do that because this is not like an odd thing or like why would they do that? It's because that's what's going on in their model.
We don't dispute that. They both have refraction involved. The problem is the globe is basically inferring their refractive index is way above anything that's ever been measured in order to make rational reason why the star takes so long to occlude.
I see.
It's like the refraction index that they're incurring for the celestial refraction, which is what they start invoking. It's just got they're begging for it. And they want you to believe in that.
I think like the next task for Flat Earth should be is to go out and to measure and make sure that the refractive index is correct everywhere, right? If there's such a contention with it, go out and measure all the data and start documenting it and find a mean average of what your refractive index should be and see if it's wrong.
We don't dispute the most of the they're incurring refraction outside of the system. They're not just using terrestrial refraction, they're using celestial. Like you want someone to go measure celestial refraction? Like who do I call? NASA?
Well, how would you measure celestial refraction?
I mean, it actually pops out in this formula that you're testing it. So basically,
it'd probably be based on like distance and your lens value and stuff like that.
But they're not using it in this
you're
process.
Actually measuring refraction.
They're only using terrestrial because like they're doing mountaintop to mountaintop.
You're looking at You're looking at the live. I didn't see that. Yeah. Okay. Let me look now. I thought you were talking about like satellites, satellites and stuff like that would differentiate. So you're talking about global refraction. Is this with an atmosphere or without an atmosphere? This graph you have up.
Can someone give Demon Stride real quick? So it's regarding the Theo experiments. You aware of that? We're just trying to fill you in real quick.
I'm looking at his live stream right now, but this only applies if there's zero atmosphere, correct?
What do you mean this only applies?
I mean, I see straight lines everywhere, so I would say yes.
I mean, this would apply in like a sphere with light in a vacuum without any atmosphere, but like this wouldn't apply on the Earth. Do you have like refraction built into it, or you're just going off angles and shit like that?
No, the thing that they have built in is this advanced spreadsheet. This is just like a diagram to like show an idea. So
okay, all right, that makes more sense.
To me, it would make sense though that the diagrams, the angle should be concrete and not changing, while the rest of the math should be the variables that change, such as light passing through atmosphere, or whether or not you want to.
That the constants of the light and the angles would be persistent. It's the fact that the atmospheric measurements can change based on where they are on the globe, the temperature of the day. All those things are variables that will affect these measurements that he has. So that's I was asking if there was an atmosphere within these calculations on here. But other than that, like, yeah, this is what we would expect, but also apply atmospheric refraction to any of these variables you're trying to
You want to know an interesting tidbit, Demon Stripe? It
Sure.
seems the flat Earth side and their overall Theo. I'm not trying to strawman it, but they're assuming straight paths of light to the fucking stars, dude.
Well, exactly.
It's
So
not that they're
even on
assuming
the
straight
globe,
past
even on the globe,
light.
it's not a
That's
straight
not what
path.
they're
It
doing.
goes through some atmospheric refraction. There's some warping, especially if it's like deep on the horizon, like where stars just start to disappear right above the horizon. Even on the globe model, you're gonna have extreme atmospheric refraction. So I don't know why it wouldn't be applied in the globe model, but it's not an argument or a problem, honestly.
And then what I see, did you want to go, Gio?
Oh, I was just gonna say thanks. You saw me lighting up. I was just gonna say that the globe model on the other side kind of has this claim that all the starlight is coming in straight lines. The whole parallel.
It's only coming in a straight line if it's coming straight down. Like imagine a basketball and you have like a light in your room and the basketball is right underneath the light. That light would likely be less refracted from any other light that's coming in from the angles from the side. So when we talk about starlight coming in, we're getting geopositional positions. Those are directly from like a 90 degree. We're not talking about ones on the horizon. So
right, and that's why they turned it off, because they're using those numbers. Because if you can take one measurement and get that zenith, which is what you're talking about, right, directly above you, then that's the true position of the star. So when they did one, they had a paused time frame of reality. They had the true position of all the stars, right? Because if one GP is correct, all the other GPs are correct. So there's no necessarily, this is their argument, is there's necessarily no need, if you want a more accurate measurement or observation and you have the ability to, then you should turn refraction off, because it's less distortion and you're doing real geometry with the true position of the stars now based off of their GPs.
Well, I understand that. And I would say you have the best position when it's directly above. Anything other than that, you're dealing with like atmospheric refraction you're gonna have to computate for. But it's not even that's the position of the star. That's just like the location that the star would be beaming 90 degrees down on the plane of the Earth that is rotating underneath it. Like, and it's only just for your position on Earth. It's not for even the star position in the galaxy. Like, that's the crazy part. Like, this doesn't even include its rotation around its galactic framework or our movement through it. This is all just to be like, oh, it's to obfuscate that, oh, you can't know this star was actually there because Flat Earth says, nuh-uh, right?
No, they're claiming it's there, and they're using that position.
No, they're claiming it's there because of bendy light and magic light based on Walter Bislin's model that they've now accepted. But the rest of Globe Earth would say that the star is where it is, and you use your position based on its.
No, dude. Hey, check this out.
No, dude, really?
No,
yeah,
my
no,
apologies.
they're using
yes,
stellarium.
really. Right.
We're not using stellarium. People have been using the almanac for farmers for hundreds of years has been accurate, and you think that we're like they used stellarium 100 years ago, really?
Well, stellarium is just basically planisphere software, or planetarium software. Well, it actually is planisphere software as well.
How did they apply that 100 years ago?
Planetarium.
Yeah, 100 years ago. How did farmers use stellarium?
Well, it was it's called an ephemeris, and an ephemeris is a compendium of basically all of the degrees of positions of all the celestial bodies. So ephemerae have been used for who knows how long.
An ephemerae would be a tensor to an equation that you've applied, correct?
No, the ephemeris is basically
an
just
ephemeris is a tensor to an equation, correct?
No, it gives a listing of all the degrees of all the celestial bodies. So it's just literally a list of all the degrees of the celestial bodies. So like if the
are they consistent throughout 100 years, or do they change?
Well, that's a good question. You're saying whether the stars change or whether
Well, I mean, you could just look up Farmer's Almanac, or you could look up all these things over 100 years. You could see if they change. If your claim is that they don't change and there's just a fixed position, that's your claim. It sounded like you made. If that wasn't what your claim was, I'd allow you to change your position now. Do you think it changes in 100 years or no?
I don't think anyone's in the mood right now to try.
I'm asking. I'm sorry, bro. I was talking to Gio right now.
You're kind of like sidetracking the whole room's conversation.
No, but me and Gio were just having a back and forth. I'm sorry. It's cool. If Gio doesn't want to answer, he doesn't have to.
No, it's all good. What is we got to ephemeris's because of celestial positions, or how did we get here, or what?
Yeah, because there's because you can position the stars and have a geo position over the Earth, but then like those positions actually change throughout the years. So like, are the farmers' almanacs wrong, or can you just apply a certain equation to just figure out where they're going to be?
Well, what are you saying has changed? I mean, you have wandering stars, you have the sun and the moon, you have what they call the fixed stars. But even though the fixed stars also,
well, I mean, even the poles have changed over like course of 100 years. Would you disagree or agree with that?
Can you provide evidence of that?
I'm sorry, I'm talking to Geo right now. I don't think Geo needs any white knighters right now. Honestly, come on, bro.
Yeah, it wasn't white knighting. I was just.
I'm just talking to Geo. I'm sorry. I'll go on mute if you need to talk, but like, I'll go on mute.
Well, he was just interjecting, I think, but
yeah, it's probably better that way.
Does Geo? So Geo, do you need him to do that for you? But I thought we were having a back and forth. It's okay.
You said you were going to go on mute.
Well, I was having a back and forth, and then somebody was white knighting for Geo. I don't think they need to though. I was having I was just talking to. It's okay. They'll mute me if they need to, but I was having a back and forth with Geo. It's okay.
Wow. Well, it was kind of it's just an open panel. If you want to do like a debate or a one-on-one, we could. That's a different thing. But
I'm just saying, felt like you wanted to jump in because you jumped in, so I thought it was a conversation between me and you at that point.
And start the 5 minute
that
timer.
way for a minute. It shifted. Hold on for a sec. You kind of, that's fine if you're asking me questions or whatever it is. But what was the topic originally? Well, in terms of what you just said, I mean, in terms of have the stars moved, that's just a deep question. I mean, I've only been alive since 1981, so that's all I can confirm. Other than in terms of what's going back in history, I mean, I know there's the idea that the pole star used to be different. From that whole globe argument is more of a globe claim because they claim it would have to because of the precession of the equinoxes. Whereas on a planar Earth, you don't have to have an axis of the ground changing. You just have the sky changing for the precession of the equinoxes, so it doesn't need that. But it does need that for the globe model because they claim it's caused by the whole Earth itself moving. Therefore, it has this conclusion or this resultant effect that the axis would have to change. Therefore, the North Pole would have to change. But I haven't seen any evidence of that because I'm only lived since 1981, obviously. So I don't have evidence that the pole star has changed. It is something that's claimed. But in terms of ephemerises, though, that is a whole interesting discussion too, going back to the history of ephemerae. And
well, your belief that the pole stars are the position they are, you believe they are where they say they are? Yes or no?
Well, I don't have to believe it. I can take angle. I can look at Polaris. We all can see it.
Have you done that? I'm curious because I haven't myself, but have you?
Yeah.
What tool did you use?
You have to set up a sundial, for example.
What tool did you use to do it?
To do what? To look at Polaris?
To gather the angle to Polaris from your position. What tool did you use?
Which time?
Extent.
Anytime. Would you pick any one of them? What tool did you? Because I want to do it myself. I want to follow Geo. How did you do it?
By a sextant.
No, Geo. How did you do it?
Dude, it's so disingenuous.
That's not Geo. That's XFOEG. Come on, that's not Geo.
No, I literally just.
I'll go on mute till Geo talks. How about that?
That'd be good.
Are we getting like server rated or something? Like, what the fuck's going on?
Server rated by one singular person who's having a conversation with Geo that you
like
guys keep wanting to white knight for?
Like,
okay.
No, it's just this animus all day for some reason.
It just sounds like Geo made claims and I'm asking him to like just simply go back and forth. It's okay if you need your. It sounds like you need to mute me.
It's this simple. One person is asking a direct question to another person. Several other people are answering. I don't know why they're doing that. You shouldn't be doing that.
For a couple days, so he's getting a little cranky.
No, just wait for Geo to answer. That's all.
The question, Geo, was so you measured your angle to get your thing set up. I'm just curious what tool you used to get that angle and how you knew it was accurate.
I'm trying to imagine like a party in which like a guy rocks up and puts his elbows out really wide, and then Andy comes in and says, "Oh no, like let the elbow go." Like we were trying to talk about diagram that I had up in the share screen.
My bad for being in an open room where people made claims and then I asked them to back them up, and you fucking want to monkey hump the room and shut me up. Okay.
We were talking about something else.
You really like.
We're actually
if he wants to run away while you guys throw stones at me, that's fine.
It's all, let's take it easy, guys. Demon Stride's feeling it. We all feel it. He just wants to debate. If someone wants to debate him,
we were
okay.
talking about something else. It's just like this chicken turned up with his elbows held really wide, and he's like inflated himself.
Hey, Rixky, do you
like
have
a
an answer for
pufferfish.
Geo? Since you want to answer for him, do you have an answer for the question I asked him? If you were following or you weren't
Dude,
following
we
and
were
you don't
talking
know what
about
I'm asking?
something else. I'm not following your
Oh, you weren't
conversation.
following the conversation, but you felt like you needed to butt in.
man.
Okay.
Well, you
He
got
really
support
looked
from
at
Andy,
debate
so just go
stuff.
get Andy to rile you up.
Oh, I'm sorry. I'm good at this, but fuck y'all.
No, Demon Stride, why are you
I'll debate
ignoring
you
me?
on whether you're good or not. I'll do that. I'll
I'm
debate
just
you
waiting
on
for
how
Geo
bad
to
you are
like.
at
You guys can be
debating.
quiet and let Geo respond to me. I was simply asking him a question, and you feel like he can't answer,
Good.
so you start talking for
Oh,
him.
it's
It's
so
sad.
exciting to come and chat with you.
I wasn't.
Andy,
I
Andy,
didn't
hold
turn
on.
you
You guys,
down,
hold on.
Stride
Rixky,
needs
like
some
I usually.
support.
Rixky, I'm turning you down like I normally
Andy
do.
need.
Can you guys hold on for a second? All right, I just got back.
You
so
can't put me down.
All right, hold up. There was a conversation occurring before. I jumped in for a second, but I was trying to add to the actual conversation. Demon Stride, we can talk anytime. We can have any of these conversations. But at the moment, what was the topic
Oh
on?
shit! Run away. All right, I'll go on mute. I'll leave,
back
Geo.
in.
Fuck you.
Anyways, I came in. I saw you were sharing your screen, and you guys were talking about Theo. You were talking about angles, and then somehow it got shifted over to like GPs, and then. So where were you guys at in the conversation?
Something about elbows
No idea,
out,
but
pufferfish.
I lost. This became unsavory when I don't know. Andy's jumping in to say like, you need to shut up or something. So it's all just like a mess at this point.
Dude,
does anyone
don't
want to
do
recollect?
that. Don't do that. Don't do that.
Shut up, Andy.
Look, the fact is, if he asks Geo a direct question, Geo's a big boy. He can answer it. That's all. And
No
everybody
one's
else was
trying to
jumping
answer
in.
for Geo, bro.
Everyone was jumping in. Don't do that,
dude. Are you just a rookie?
Well, the thing is, I came back to my mic only for a second, and I shared Risky's screen, and then they were having that combo. I jumped in to say a few things, and then it seemed like other people were trying to join in the combo, and then Demon Stride started like screaming that he only wanted to talk to me, and then I wasn't at my mic when he was doing that. So sometimes I'm at my mic where I can really go back and forth. Other times I kind of have to jump back and forth. Anyways, I was listening, but I wasn't really able to. So I don't know what he was. He was talking about angles to players, how to take angles to players. Is that what he wanted to ask me?
Gotcha.
Well, the last thing I said is that you have to measure an elevation angle to players to set up a sundial. That was the last thing I said. So.
Yeah, and then he said you did it. He wanted to know what tool you used to set up your sundial.
Oh yeah, something about the accuracy.
Sorry, Rager. I just wanted to finish. I told him a sextant. He said I was white knighting for you, and then lost his shit and left.
He did mention something about the accuracy. How did you confirm the accuracy of the tool? Something along those lines.
I didn't notice him losing his shit and leaving until Geo attempted to readdress the situation and ask him what the hell was he talking about. That's when he lost his shit and left.
Yeah, I blame Rixky. It's all your fault, Rixky.
You white knighter, you.
I just blame Demon Stride for his poor social skills.
Well, he was wanting a duel with Geo, and he wasn't getting what he wanted fast enough, I think is what the problem was. And then when he did get it, it was, nope, never mind.
Yeah, when Geo weren't responding, I got the impression immediately that he's probably busy, right? I mean, that happens. So
why'd you tell everybody to shut up?
Because that was the right thing to do.
Was it police the whole room while Geo's not here? And he's not going to respond?
Do I need to educate you what social etiquette is, Purig? I think I do, actually. How old are you, dude?
Dude, don't come at me like I'm asking you if you
wait a minute. You came at me. Let's get that straight. You came at me.
Talking. Now, let's get this straight, motherfucker. I'm talking. Don't interrupt me. If you thought Geo was busy, if you thought Geo was busy, why did you tell everybody that was responding to shut up and wait for Geo if you know he's not going to be at the mic?
I thought he was busy after when he didn't respond.
Let's just move on, please. Everybody, just cool your jets. Maybe
Yeah,
we
well, I
can do
think
it
what
in
It's a common trait. Andy seems to do this sometimes, like tone police people and stuff. He's done it to me a couple of times.
Try
I
and
don't get it.
help people be grown-ups. Yes.
Still talking about people. How about we
You're
get
so
an
much better,
actual
Andy.
subject?
Andy, you're
You
so
should
much
know
better than
the
everybody. My goodness.
Well, you're
yeah,
like
the
a bunch of
dynamics of the
babies.
conversation. No,
You're
dude.
like the
Still talking
pinnacle.
about people. How about we talk about some global Earth curvature and where they've measured it from? Oh wait, they haven't.
Well, hold on. There was the top. Okay. Demon Stride started wanting. He was asking. Well, we were talking about stars and the positions. It is the case on the globe model that the starlight does need to essentially come in straight, and it needs to travel through space in straight lines as well, at least to a degree, to have the whole celestial sphere even work at all. So, yeah, so that it's not necessarily implied that the stars are always in some kind of like bending position. And the fact that the true positions are consistent with the GPs, that's what we were talking about, I think, before that all happened. And if you have consistent GPs with all the stars, and then the angles would all correlate with that. So it seems like being able to measure a starlight occluding, maybe it wouldn't be completely, I guess everyone would choose whether they think it's exclusive evidence or not, but if one matches the prediction and the other doesn't, that's what globe folks often say, is that, you have to have your model be predictable. In this case, the globe is not the one that's able to be predicted, so.
I missed that. Which part of it's unpredictable?
The globe doesn't predict the distance or the altitude correctly, and the planar Earth does. You do one or the other to derive the distance based on the timing of the angle.
Oh, are we still talking about Theo?
I don't know. I kind of came in. They were on that, and then stars, and then Demon started asking questions about ephemerises and stars and angles, and I mentioned something about because he brought up the North Star moving, and I mentioned the precession of the equinoxes, because the globe requires that to change, and then, yeah, we're talking about taking angles to Polaris. That's what I remember from the last set of topics. So I was just picking it up from there. And yeah, they were talking about Theo earlier.
Yeah, one thing I hadn't considered with Theo before is B-Skills was saying that this 15 as the star gets near the horizon, it slows down, which the globe claim is due to refraction lifting it up. And he said, well, that would be expected on a planar surface because with perspective, things would drop slower as they got further away. So I thought that was interesting. My question would be, why it doesn't follow the laws of perspective anywhere else. And it was raised by, I think, I forgot his name.
But what do you mean anywhere else? Anywhere else in terms
Well,
of...
just like because the law of perspective says something gets twice as far away from you, it should appear twice as small.
Okay, so that's
and it should take twice as long to move downward in the sky. But we do see a consistent drop of things in the sky. It's only when they get near the horizon that it slows down.
Perspective has to do with how we see. It's how our visual apparatus constructs the image that our mind sees. What we're talking about is the actual path of the light. This is independent. I mean, perspective's involved. I mean, ultimately it constructs how we see, but this is the actual behavior and like rudimentary geometry of the light path itself.
Yeah, but you can't separate the two, though.
But you prove the light path.
There's no way to separate the two, though. Like, it's always, unless you're up close. If you're doing everything up close and like a, I don't know, footage distance, then yeah, I'd say you could go off of like one or the other. But once you start going like miles, no, forget it. You have to use both of them.
Yeah. So, well, the rate of things fall. What you're saying that it doesn't match planar trig, Pfinky, because
I'm talking about the
slow
path.
down.
So the
slow down.
angle. Yeah, but I'm talking about like the angle in the sky and the size.
Yeah. Yeah, it functions sort of like but it does slow down like with the planar geometry. When something moves over you, it does slow down at that rate. I'm not saying that proves that like the stars are on a plane above a plane, but the rate at which they slow. And now you're saying it does match that with the planar, but it does not match, for example, angular size change. Was that kind of your point?
No, it doesn't match. It doesn't match either.
Okay, so you're saying it doesn't match either. Okay. Well,
correct. Like
also,
what we
there would
see
be
in
a
the sky is everything moves at 15 degrees per hour. Whereas with just perspective and planar trig, you should see that the further away it gets from you, the slower it moves down in the sky.
Yeah, but
like
that's not.
you should never see a linear.
But that doesn't become significant until it gets close to the horizon, closer to the horizon.
No, it should be. I mean, it. What do you mean by not significant? I guess.
Well, if you took like I could pull up a graphic thing, but if you took like a little hemisphere, like a planetarium, and put an observer in the middle, and then if you put like a parallel line above it, so it's like planar line, let's just say above that, and then you have the hemisphere, and then you take like a sun, for example, as an example, like on that planar line, and then you just above the Earth, and then you move it across it, and then you draw a line between the observer and the sun, you can actually see the angle of the where the person would be seeing it in that hemisphere as it moves across the plane. And that's the whole like 1 degree per 69 mile as well component. But as that would move, like if you're in the middle of that hemisphere and you have a planar sun above it moving, or a sun on a plane basically above it, that line that intersects between the observer and the sun is going to like, basically, if you connect it to the sun, it's going to
I don't know. Like everything cut out.
Oh, dude, my push. Oh, the server did one of those resets. You know what? I'm gonna try to change it to a different server because you can. It's on automatic right now. I'm gonna actually change it. Here, give me 1 second. It might do a little short blip out. All right, are we back?
Yeah, I can hear you.
Yeah.
All right, I just changed it. So basically, Discord for VCs, you can put it on automatic, or you can choose between. Yeah, a couple places: Brazil, Hong Kong, India, Japan. Anyways, and then they have U.S. Central, U.S. East, U.S. South, and U.S. West. So, anyways, you can put it on one of those servers. I'm gonna try that and see if that solves all the resetting.
I think as different people join, it tries to lower the latency based on the best server. So if you just set one, it won't do that so often.
Okay, or it's just a thing with Discord. I guess we're gonna see because I just changed it. So I put it to U.S. West. I've had it on U.S. East at other times too.
East is better.
Should I flip it to East? Do you think East is better? Well, you got like the New York thing, but then like all the Silicon Valley is on the West Coast.
Bro, put it on East, dude. I need the help. Every help I can get. Put it on East.
All right.
Only because that would be central to between the Europe
Shut
and
up,
the
Rob.
Australian and Western guys.
Put it away from Canada.
You want me actually to flip it to East? All right, I'll do it. It's gonna. It usually
I need
cuts
all the
out.
help I can get, bro. Come on.
It cuts the. All right, for Jeremy.
Up for you, Jamie.
I'll do it for Jeremy. Well, just when I glanced at him right now, for some reason my intuition went with West that it would be better, but All right, I just flipped it to east though. Okay.
Oh, it's already better.
It
I
feels
love it.
already. Yeah.
Is that better?
And I'm still here, and I'm on the west. We should be okay.
Oh, you're coming in
Yeah.
All
better.
right. Everything survived. Nice.
You guys didn't like me and Rob on the west. You wanted to go Brigger and Jeremy on the east. All right.
Thank you.
Yeah. We'll try this. We'll see if we'll see if it keeps doing the channel reset. That would be. I mean, if we find out that it is that automatic setting, that would actually be pretty cool if it stopped happening. But if it's just Discord, then this won't make a difference.
Moto's on the east too.
All right, we're rocking the East Coast right now.
East Coast.
Oh,
Beast-
so what I
Beast
was
Coast.
saying. What I was saying is
you guys are the fresh coast over there. Sorry, go ahead.
no, just if you have the hemisphere and then you put a sun and a parallel line above that. Okay, you have a flat ground. Then you have a planetarium or like a hemisphere on that flat ground. Then you have a line above it that's horizontal, parallel to the ground. On that line above it, you put the sun. You then put a line between the guy in the middle of the hemisphere on the ground and the sun, and then you move the sun, on a parallel line above the flat Earth or the planar surface beneath it. And then when you can see the line, where the line intersects on that planetarium, it is like, it's kind of that range between like 30 and 70 degrees that they claim that they use in the celestials, between 30 and 70. And that's mostly where the 1 degree per 69 miles has also been claimed to be observed, between 30 and 70. So that's the thing. There's like a band there. But when you look at that band with a parallel sun kind of object going above a plane, and you have that line that's intersecting, therefore the line is going to somewhere intersect with that hemisphere between the observer and the sun. And where that line intersects with the hemisphere is where you can see, how that sun would be setting on his hemisphere, basically. And it doesn't start to get really stretched out until the sun gets really far away above the plane. Then the angle, it starts to go a lot slower than 15 degrees an hour.
I'm gonna try to create like a simple graphic that we can look at. I didn't understand what the hemisphere would do, because like, why would we need a hemisphere in this model? It sounds like we just need two parallel planes, right?
Well, I mean, it was just what I was describing. Like here, this, for example, actually shows it. This is from some like old book. And this is how they say it. They say within his eye-formed atmospheric tent. So they call it an eye-formed, EYE, eye-formed atmospheric tent. So they're obviously saying it's formed by your eye in some way, and then it's an atmospheric tent. And it says here, I'll read this. It's kind of weird wording though, but it says, "At a man in his tent must be, he through its bounds can't enter. No matter if on earth or sea, he's in his own eye's center. Where'er he moves, his tent moves too, and then he gets a different view." And that's basically what I was describing.
That's a lenticular lens.
Well, if you add lenticular to it.
That's just, he just described a lenticular lens.
But that's more or less what I was describing. And it even has the lines going from the sun to the guy in the middle. And you can see where it would line up on his, what they're calling the eye-formed atmospheric tent in that little, which I actually don't know what that is from. I have that. I saved it, but I actually don't know offhand what book that's from. But I've always had it in my folder.
Wait, where in sorry, where's the guy in this?
In the middle of the hemisphere, just like it would be in a planetarium. You're always in your own hemisphere. Like a planetarium is only really accurate when you sit in the middle of the room. Technically, you're supposed to sit right in the center of the planetarium. That's the only place that's actually fully accurate. Every other position is going to be kind of skewed. But I mean, it's still fun to have a big one, have a bunch of people inside of a planetarium. But I'm just saying a planetarium. So in the same way, yeah, this would be in the center. That's.
See, I interpreted this for like you're looking at street lights getting smaller and converging, like a single point art, like a single vanishing point art project or something. That's not what it is?
Wait, for what? By the way, this animation is pretty cool too. that shows how we see the sky above a planar surface and matches to a planetarium. And I don't know, I mean, whether those miles are the case or not, but it is one way it can. The 6210 number is actually the distance of the arc of your range of vision.
Oh, I think okay. I think I get the graphic now. I was looking at it. It's more like it's an orthographic view.
Yeah. Well, I mean, what is the nature of that hemispherical range of view? Yeah. I mean, that's a good question, but the thing I was pointing out about it is just simply like, and also that animation I posted, which does have a straight line that goes from the observer, even though it's not necessarily the sun in that little animation, but it shows like a sphere, but then a dude on a flat plane in the middle of the sphere. So that's the inversion I think that's been done with the globe model, because like that 6210 number is actually the distance from your horizon to your zenith.
But Gio, how does planar geometry apply to that with regard to perspective? That doesn't look like what I would assume to be planar geometry and perspective.
Which one?
I mean, as far as like things in the sky relative to your position, how would perspective, there's an equation for that, how things would drop in the distance with, as they move away from you. How would that equation work with that spherical sky above you? Work with that spherical sky above you.
Well, I would say the whole matrix of perspective is spherical, or it has a spherical dynamic to it. So, and what I mean by that is, I'm just grabbing an image real quick. Like something like this grid, which is just like a basic kind of perspective grid. If you were looking, okay, if your feet were going all the way to the horizon, like a radius, and then this whole thing was a sphere, let's say, but your feet, let's say the radius would be of the sphere would be your feet all the way to the horizon. That would be like looking upwards at the top of a sphere, but the sphere is like horizontal. So imagine like the north pole of the sphere or whatever, or the top axis of the sphere is actually at your horizon. And then that whole like pyramidal structure of the perspective matrix that comes out is linked to, it's really linked to toroidal geometry and the nature of how a toroid is a sphere. And then how a pyramid fits within a sphere. So perspective is like a pyramid with all those straight lines, like you're looking to the peak of the pyramid, but it's also turned on its side. But that peak of the pyramid, that if you were to look up from the middle of the pyramid upward, you'd see all the lines all converging at the top of the point of the pyramid. If you put that down sideways, and now you would have the perspective matrix, that whole pyramid is how perspective, but that pyramid also has spherical geometry built into it. The way a pyramid fits within a sphere, it's just the straight lines, but then you have the base of it. So I think it's linked directly to like spherical geometry, with that perspective matrix also having the pyramid built into it, which ultimately is all toroidal. Sorry if that was too long-winded of a response for a faster pace, but you were asking how perspective is connected
No,
to...
that's it. You did good.
How perspective is connected to sphericity. Basically, that would be the question.
Yes.
What do you think on it?
Well, I mean, I would relate it more to using the word perspective as how it looks from where you're at versus the law of perspective. I think it'd be probably categorized in two different ways, maybe.
Well, like, why do the train tracks converge? It's pretty wild. Why do they look like
that that would just be things, you know, having when you double the distance, they're half the size. And at some point, that size goes to unresolvable. You know, it just gets smaller with distance until you can't see it.
No, with the parallel lines of train tracks converging, I hear what you mean with angular size. Are you saying the parallel lines of train tracks have to do with the angular size of the track getting smaller? Because I would say that probably is linked to that.
Well, the distance between the two tracks gets smaller.
Because the angular size of the tracks as a pair gets smaller, that's why the train tracks come together. Were you linking that? It's kind of an interesting way to see it. I'm saying, were you linking it that way? That like the reason the train tracks look like they're converging is because they're changing angular size, and then they get tighter together.
Well, yeah, they just appear to converge as they go, which I understand that to be the law of perspective. You know, if it was a cube, you move it. You know, if it's occupying 1 degree of your vision at 10 feet, if you move it 20 feet away, it'll be a half a degree. You move it another 20 feet, it'll be a quarter of a degree. You know.
Yeah, that was sort of my point earlier, Gio. I posted a graphic. I just did this in Claude real quick, but it's at 6:34, so 34 after the hour. But the point, and Left Lane was touching on it, that every if you move it away an equal distance, the amount that it shrinks gets cut in half. So instead of it goes from a whole degree to a half degree to a quarter degree, right? The angle, there's no linear change in angle with distance. And so this graphic that I created, what I was trying to show is that the sun moves at a linear path up above you. And as it's moving away, and I'm doing like equal increments so you can see it, but the angle that gets created by the sun with the observer, it doesn't go in an equal degrees per hour. And even though that's what we see like a 15 degree per hour movement. But what you would see with perspective is like a much higher degree per hour when it's above you and much, much lower when it gets further away from you. That's why I say it doesn't follow the law of perspective.
This is 1 degree. This is 1 degree per 69 miles.
Following the laws of perspective. I think that's only terrestrial. Sorry,
I just
Gio.
posted this real. No, you're good. I just posted this real quick. This shows 1 degree per 69 miles over a plane. Gleam actually made that. So it does work over a plane.
Well, I mean, he's admitted that he put dark angles in there. There's an extra fudge factor.
I think Seafoam actually made this version where he threw people on it. It showed how the angles. It's funny. But you notice that's like a curved matrix, which is interesting. Meaning that
I think Gleam
we see in a curved way, not the ground being curved.
Yeah, I think Gleam gave you some fool's gold. I think if you actually go and you just draw it, kind of like I did, if you draw it out, you'll find it doesn't actually work. And part of the reason is because he uses
it links all of the points from the observer.
Well, but he invokes curve by saying 1 degree per or 160 nautical miles per degree. That just by itself can't be reality according to the law of perspective. And so if he uses that to make a diagram, then yeah, it's going to work. But he's sort of like he basically snuck in the globe at the beginning, and then never explains. Like he calls it dark angles, which is just his way of saying make up the difference for why it doesn't work.
Okay, I don't know what the dark angle claim is, so I'm not going to respond to that. If he says that, I would want to hear his view on it and not only hear your side, I guess, if I'm going to respond to that. So I would just rather hear, because I haven't heard Gleam say that, so I'm not sure what you're referring to with that. However, what this graph shows, I don't think it has anything to do with being fool's gold, because what it just shows is essentially if you have an XYZ matrix, meaning like the ground, horizontal, you have a vertical, and then you have a point at the top of the vertical and a point at the bottom, basically a triangle, which would be like stars over a planar surface if you're going to want to go that route. So it takes that basic, just the basic 3 points, object in sky, GP, and then the observer, essentially. And then it just takes lines going from the observer up all the way up the vertical. And then if there was an observer at the star looking down, it goes from the GP and spreads along the ground. And if you just draw those lines, it ends up looking like this, because it shows the one I posted of his on the left, he's got all the numbers. So it shows the 1 degree per 69 miles all the way through 90 degrees. And you get that 6210 number as well. He has 6214, just the slight variations. But yeah, that's the 6210. So he just shows like, yeah, the latitude, the distance, what he calls apparent altitude, which would be because if the star is not changing in actual altitude, but it looks like it's setting, obviously that's an apparent effect. Like it's not actually falling downwards just because it's setting. So he calls that apparent altitude. And then he has the hypotenuse, which gives that 6210 when you go all the way through the 90 degrees. So it's just showing that. And it is interesting that it makes like a curved matrix, but what I'm saying is that all those plots pointed over a planar surface, without any conflicts. And that it just links to
I'll show you how to deal with this. I'm familiar with this spreadsheet. What height does he put Polaris at?
He's also look like corpuscular rays. But the Polaris, it's just the apparent altitude, because it's all Polaris ever really is. Like we can't get to it to know what its real altitude might be, so it's always apparent. Now I know
he put it at 3,009.
They've changed.
He put it at 3,959 miles, and you can tell because the very top one, when you're right below Polaris, you're looking up at it on his spreadsheet. Polaris is 3,959
miles. He starts
miles.
it at 3,959. Yes, that's what it starts.
But that's where it stays, right? Like we need to draw it like the diagram you just described to me, because you don't think Polaris actually comes down in height, right?
I would just say that I don't think any human has the ability to tangibly verify where Polaris actually is. We view it as a thing we call Polaris, but as far as I know, no human has ever been able to tangibly confirm it as a physical thing even, or the distance of it. We just see a position. In the heliocentric model, they've even had to change it by many, many light years, because they thought they were off or whatever, and they have their theories. So they don't know either. They just have ideas or theories, and involves light years. But I don't think and so that's at the most quote unquote cutting edge of whatever they're pushing. And then I don't know of any other human that would have any other way to physically confirm it. So, but the 3,959 seems to have been derived from perspective and from how we see for the globe. So it makes sense that he would use that in this kind of visual matrix. Like the 3,959 is a thing. It's not, I don't think it's a radius of a sphere, but it's not like there's no 3,959 in this reality. There definitely is, but it's just where it's applied.
Okay, but the question was just the example you gave in the beginning was to have the sun, Polaris, whatever the celestial body is, moving in a parallel line above the ground.
Well, I was just giving that as the basics for like where if you have a hemispherical region around the viewer, and then the line from the sun to the person, and if that sun is going, if you do put it parallel, I'm not saying it is, maybe it changes. I mean, Jeremy's idea of a lenticular lens would mean that it would be a whole different type of thing. It wouldn't be like even a physical, thing. It's more like I would even add to that possibly like some kind of like crystalline, multi-leveled refractive medium of some sort.
But even then, the sun's staying at the same height. It's just the apparent height's being changed by the lens, right?
Well, I mean, even going to the Bible for a sec, they talk about how it's like a crystalline, like a molten crystalline, some of the imagery they use in there, and other ancient texts too. So, I mean, if it's crystalline, we know crystals can have all kinds of refractive, lenticular-like effects.
Well, we could test. Let's say we don't know.
If you do put it parallel above,
say if it's parallel above, and then we could look at Gleam's thing here, and we could say, okay, let's say just. I'm not saying that we all know this, but let's say it's 3,959 above us, right? And we're standing underneath Polaris. We're basically at the North Pole. Then all I'm saying is, okay, you can pick
that's
any.
How it works for the way we see it. That's all we know. Because all we do is ever see Polaris. It's all we can do is just see it. I guess you could shoot spectroscopy at it too, but that's about a wrap. That's all you can do is just see it and shoot some spectroscopy at it, and that's it. So yeah, that's all we ever can do. And the 3959 seems to be like empirically able to be derived from how we see Polaris and how we see the stars. I mean, Alan's gone through some of that as well, and how that 3959, that if you use that number, so does that number come from the idea that we're on a ball and then somehow derived from that? Or is it actually something that has to do with how we see in that way, and that 3959 position of Polaris being like the extent of how we see? Like, it may be that we see in a 3959 radius. Or
okay, just follow me on this though.
Or that Polaris functions as a 3959 kind of celestial radius to what we observe. And then that was then extrapolated into the globe model ad hoc for their model that they kind of brought into, then say, oh no, actually that's the radius because we're on a sphere rather than in a sphere on a flat plane.
Okay, just follow me on this for a second. So we'll just say 3959 because that's what he's set it at when you're right underneath it. Now let's move 45 degrees away. So we're basically gonna move to 45 degrees north, right? So now what that means, we know that when you're at 45 degrees north and you look up at Polaris, it's going to be 45 degrees in the sky, right? And we also know that if you're 45 degrees away, that you've moved 45 degrees times 69 statute miles, which he has right there is 31, I think he's got it, 310711, right? So then you can just do the trig, right? You just plug in the angle and the distance, and you should get a number that matches. Like if this is a real triangle in reality, you should get a triangle where the height matches what you said it was originally. But in the case of his spreadsheet, you don't. At 45, I picked 45 because it's easy. Both the hypotenuse and the height are going to be the same. 3107.
Yeah, you get 4,394 for the apparent altitude.
No, you should get 3107 is what you should get.
Oh yeah, I said that wrong. Well, I was actually looking at the hypotenuse, yeah.
Right. So, and that is perspective. So basically what he's doing is he's applying perspective, and then he's sort of applying it again by just saying that not only did it appear to move down in the sky by 45 degrees, it also actually moved down in actual height. So that's why this spreadsheet doesn't work. It doesn't.
No, but it's moving down in apparent altitude because that's all it ever is. Like if we can never get to, okay, here's what I'm saying. If you have something physical like a building and you have something on the top of the building and you move away from it, there is a certain relationship there because the building is physical. You also know where it is. You can validate it and so on. But with Polaris, it's literally like some kind of celestial manifestation, if we want to call it that. Even in the mainstream model, they really have no claim that it is a huge ball light years away, or no actual proof to that. But I mean, that's a whole separate discussion. But that's like a philosophy at best, or like a theory, whatever they have going on with that. And if no other human can get to it to validate it, then literally all we have is an apparent altitude, meaning we don't have any way to ever actually check if it is at a physical altitude above a planar surface. All we can do is just see what its apparent altitude is, basically, meaning its position, its declination in the sky, essentially, the angle of how
I'm fine with that. I think the only point I'm trying to make is this: if Polaris followed the laws of perspective, then you should get the same height when you apply the same planar trig to getting back to the height. And so when I say the skies under flat Earth don't follow laws of perspective, this is what I'm saying. And
no, they do.
You can invoke other,
but they're very far away, so they are going to be different. Like perspective is different if you're a foot away versus thousands of miles away. There's different,
right? But you could change. We know with Polaris, we know when it's straight above us, and then we know what the GP is. So we have two of the pieces that we need to sort of complete these triangles. And if it does follow the law of perspective, the triangles should complete. I feel like for flat Earth, it should be an easy concession to say, yes, this doesn't follow laws of planar trig. Something else must be going on. That's what Gleam has done here is he said, well, there's something that just makes it move. It just moves. As you move away from it, it actually physically moves because it has to make the trig work. So it's not like a debunk. It's just, I'm just saying it doesn't. This is not the way perspective works. It's something different.
Yeah, I wouldn't contest that with the Celestials. Yeah, because the Celestials are they're in a medium we can't access. It's sort of like, imagine, okay, let's just say I was just thinking about this. Let's say that we're in a little terrarium, okay, and there's some like people that are like bigger than us or whatever, and they're looking at us inside of a terrarium. And let's say that this terrarium has like maybe kind of like that like white plastic that you can kind of see through, but not really, like a white plastic. Okay, so let's say there's a white plastic all around the terrarium. So the people inside, they don't really know what's going on. They just see kind of a white plastic. They might see some colors or some shifting, but they don't know. Whereas the people outside, maybe they're like giant humans or whatever it is, right? Like in whatever analogy. But the thing is, like, there's a separation there between access to the medium. So if the people were in there and they're seeing lights or they're whatever it is, like it's like a bubble, like they just can't see fully what is actually on the other side, So in the same way with the stars, I'm kind of relating it to that. Like if they're on the other side and we're on the other side of them, meaning we can't get to them, we can't touch them, we can't do much other than look at them, basically, and maybe, like I said, shoot spectroscopy at them. But there's very limited of what we can do. So I hear you that it doesn't function as it would if it was just like a light bulb in a ceiling. But I already agree with that, so I wouldn't debate you on that. I would agree. It does work. Well, it works basically like a 3959 celestial sphere. That's how it seems to function around you on a planar surface, which is why it was even called the celestial sphere way even before the globe model. And like even the ether is connected, and quintessence, like the high octaves of the ether, are known as being celestial spheres. So yeah, I mean, I'm just saying that we can't know, so we're just seeing it. And so yeah, it doesn't function like just a light bulb in the ceiling though, at a fixed altitude. I agree with that.
Okay. Yeah, I appreciate that. I think I got on this because someone in chat was sort of like taking Globers to task because we think perspective applies everywhere except the sky. And I was like, well, I think the globe has an explanation for why things move at a linear rate, but I think flat Earth has a less of an explanation for it. My comment on the lens thing.
The globe Sorry, I was just trying to.
Not really. It doesn't. According to the globe,
they derive.
See, we put on East Coast. Now we're screwed. Go ahead.
Is it delayed? No, we were just talking over. Go ahead.
I was going to say the lens thing. You could say, well, a lens would make things not follow perspective, but like my argument with that is, when you're looking through a lens, right?
Like, how do you know the sky's not a lens? By the way, was there a delay, or we were just talking over each other? Is there an actual delay that the east is an issue, or no?
I don't know. I felt like I would go to talk, and then I would hear you in my headphone and assume that I'd mistimed you. I don't know.
Well, if I'm echoing, let me know. I might have to change my settings because I have like a speaker and a mic kind of set up, so sometimes it echoes back through. Or I was.
Oh, it's not echoing. It's not echoing.
I might have just been interrupting a little. We were just talking over each other. But if it is actually delayed, or if the East server is worse, I would want to know. But anyways, go ahead. Well, I was
Jeremy deserves it.
Or how the globe inverts that relationship. How they've derived, into what they're claiming the Earth is. So, because you were saying, well, anyways, go ahead. Solving.
There's two things there.
There's the complex. These two things are trying to solve the complex of what the sky is, and how and what you're deriving from it. But yeah, go ahead.
I don't know which one I'd rather talk through, but the lens one, I feel like we know quite a bit about lenses, and we know enough about lenses where you could, like, as flat earthers, you could use a lens to explain why things don't follow. But we also like that you can't have a lens that distorts light one way that doesn't distort light going the other way. There's no such thing.
Okay, well, that's an interesting topic. We could go on that, but what I was actually thinking is, why the sky has to be this way that we're describing? The issue you're saying with local perspective. I would say that it actually has to be that way because it was designed for celestial navigation to work over the entire plane of the Earth. If you only had local perspective effects, you would never be able to pinpoint stars that are like thousands of miles away and then be able to accurately navigate to them. So ironically, the way that this whole like sky works, it matches with being able to be in like one part of it and see such a wide range of sky that you can see basically stars so far away that you can travel thousands and thousands of miles to get to them. Whereas if it was all just local perspective, you wouldn't be able to fit that much in local perspective. You know, like if you just had a ceiling that was like much smaller and you're just having like a building and something at the top of the building and you walk away from it and you watch how the top of the building drops or whatever. If you only had that ratio, you would never be able to see thousands and thousands of miles to be able to actually do celestial navigation to then travel around this beautiful plane.
Why? I don't think that follows.
It's like
I'm kind of giving more of a philosophical, like design reason, not necessarily philosophical, because it would also be very practical as well. But I'm saying like that's why the sky would have to be designed to function at a different ratio than the ground, because you're able to see thousands of miles worth of star travel within a region rather than just a few, acres or whatever normally that you would see in a smaller perspective matrix.
I like that point a lot. Whether not trying to jump in, go.
No, you're good.
Yeah, just like a glare or fields, you have. It's all like the perspective's constantly changing. It could be figured out, I guess, but because you have to be bigger than we think.
I don't think it's the distance so much. I think it's the placement of things in the sky. I still think the only way to really make the skies work is something like the personal azimuthal dome of vision model, which isn't about seeing things further, and it's not about seeing more of the sky. In a lot of ways, it's about seeing less of the sky than you would be able to with perspective. But it's about placing those things in the sky such that, celestial navigation would work. Like, I'm confused why you think you wouldn't be able to see further without that.
Well, it's like 2 dimensions versus 3 versus, just waypoints and like airplanes do, No.
Yeah, I mean, if you have like a smaller perspective matrix type setup, like let's say you have even if you want to go with what I was saying, like a building, like even a tall building, like go with the Burj Khalifa if you want, and put like a big orange ball at the top of it, and then go right at the base of the building and then start walking away from it and then watch the ball lower in its apparent altitude, essentially, and then watch it go all the way down to your horizon, as it were, if you were to get that far away. And we would all, like, if we use the term apparent altitude, I think everyone would mostly agree, like it's not actually lowering. Nobody's taking the ball down to the ground. The ball stays at the top of the Burj Khalifa, and you're just walking away from it. So we all agree that no actual ball is dropping altitude. So the apparent altitude will appear to, that effect. But now let's say you did that with the Burj Khalifa within like 10 square miles or whatever it is, 5 square miles or, whatever that would be. That is a pretty small little range there. And so if you were to try to fit stars above that on, the huge Earth, there wouldn't be enough room for the GPs to fit on that little area that you're like on that small little 5 square mile area, or even like, that's why I was saying a few acres or whatever. If you make a ceiling, like a flat ceiling, there's only so much you could fit on that. So you wouldn't be able to actually have it to where you could be looking in like a 6,000 mile radius, which let's say it is that, half of the globe is the 12,000, which is half of the 24,900, roughly half, the 12,400 is half that. And then if you take a radius of that, 6,000. So even if we see in a 6,000 mile radius, which means a 12,000 mile diameter, 12,000 miles is a ton of Earth to fit into a much smaller region of local perspective when we're referring to like the ball on the top of a mountain, or sorry, the ball on the top of a building. I mean,
well, that's sort of my point. Like you're saying we can see for 6,000 miles, right?
I mean, let's just say at the moment we can see 6210 because I mean, Polaris disappears at the equator through the 90 degrees. That's 6210. I think there's a lot of reasons to. Seems to be that the celestials function like a 3959 radius, but we seem to actually see in like a potentially a 6210 actual range of the sky, range of the view of the sky, but yeah, so I mean, let's just say we do see in a 6210 radius hemisphere.
Yeah, so you would have 121,152,693 square miles that you could put those stars on, right?
Yeah, what was the number? Actually, because I was thinking of it in my head, and then what was the number?
121 million. I did radius 6210 radius squared times pi. Should give you the area on which you could fit those. That's a big area,
dude, because it's like things in the sky like that, the gleam, what he was showing there. So, like the apparent altitude is going to be different depending on how far away that object is. Obviously, like that apparent altitude effect drop. But yeah, like if you put Polaris at the 3959 apparent altitude, and then you lower it as you get further away from it, that seems to match with the 1 degree per 69 miles. And then when you get to the equator and Polaris disappears, that distance is claimed to be the 6,210 miles. So it's like you're seeing a 6210 arc of your hemisphere. That's what the 6210 would be. It would be from the horizon to your zenith on a flat plane. So you're on a flat plane from your horizon all the way up to directly above you. That is the 6210, meaning you can see 6210 worth of that arc. And then
yeah, I mean everybody sees half the stars basically.
The distance from that ends up being 6210 from the equator to the North Pole. But Polaris functions as a 3959 object that drops. So there's something with that too. And this is what needs to be sorted out as to how the cosmology, which one's correct, because these are interchangeable between models.
Yeah, so I mean, my take is I don't see why. I think there's plenty of sky, and if you can see if we're saying you can see for 6,000 miles, then you should be able to fit the stars up there.
Well, I'm saying more that you're seeing.
Take a look at the whiteboard.
You're seeing a 6210 arc distance in your view. But go ahead.
Take a look at the whiteboard.
The whiteboard. Am I back in school?
Oh, dude,
I don't know what the whiteboard is.
So you're saying Polaris is in the north, right?
Wait, hold on. How do I see the whiteboard?
Yeah, hold on. I gotta join to it. Well, I can. Do you want me to share it on a screen share?
Get out of town. I love whiteboards, but I'm going putt party.
Yeah, you can share. Where would I see it though?
Well, it takes me just a second, but I can actually make it a screen share, so you don't have to actually join the event for people that don't want to join it. But you can join the whiteboard directly.
Oh, I see it up there. Whiteboard join activity.
Yeah, just click join. But I'll do it on a screen share as well, since I'm already kind of doing it now.
All right, Elbow, draw me something pretty. I see Colt.
I don't agree that you can see half the sky. No, practically. The reason,
I mean, like roughly, you don't think we see roughly half the sky?
No, no way.
How much do you think we see?
Check this out. So if I was in the equator and you said you could see Polaris, anybody in the equator, can you please stop moving the world?
Is that me doing it? I don't know. I'm just trying to zoom out. I don't know. All right, I'll just watch. Go ahead.
Here, I'm getting it. Here, I got it finally shared. Sorry, it took me a minute. Elbow, you're actually it's all sharing now. Then anyone who wants to join, here I'll change it. Just join this screen
Sorry.
share.
I think my mouse was engaged. All right, I'm just gonna go watch it.
All right, I called it screen share up there, so anyone can just click that. But all right, Elbow, I got it all going now. I think you're good.
I need the globe moving around for this. Just give me a second, y'all. All right, so check the star out. Okay, nice. Say Polaris up here. A person that's here, let's say the equator, right there. They can only see what's man, what can this thing be thicker?
Yeah, that's the equator, the equator on the left, and then if the North Pole is at the top.
Right.
Yeah, so that arc distance
they
they
can
claim
only
is 6210
see-
on the globe.
I'm saying they can only see what this flat line is.
Which goes off light years to Polaris, they claim, yeah,
Right.
basically.
So, but Polaris is up in the north side, right? Up here, somewhere.
Well,
up
that's
north?
why they have to say it's light years away, though, because it's not local. It's
Yeah, but in other words, the person's view has to be. He has to be majorly huge. Like that person has to be,
at a high altitude.
Yeah,
yeah,
it has
but
to be like way up here. Like he
if
has
you're
to
on-
be at least 20 foot high.
If you're on the equator, you're not going to hardly see Polaris anyway, because Polaris is the North Star, so it would be
but-
barely on the horizon
yeah,
or not
but
be able to be seen at
Polaris-
all.
But Polaris will have to be somewhere up here.
Polaris is right over the North Pole, straight up,
Yeah, but
right in the
straight
center.
up- so, come on, dude. Can y'all take the fucking dude out the way? Please?
I don't know who's doing it. I'm not doing it. I'm just talking.
So if
I'll bet it's
Polaris
fresh.
is
I'll bet it's fresh doing
north-
it.
Right there.
Why is he-
That Polaris is right there in the center.
Yeah, you guys don't troll right now because we're actually trying to do this. So you can create a different whiteboard and play around if you want, but don't mess up this one. But go ahead, Elmo.
So where
if Polaris up
was
north,
the where
right?
was the
And the person
people
can
at
I,
that
can I, hold on. Can I move your?
I'm
Can I
asking
move
you
your
a
mouse?
question.
Hold on. Well, I'm trying to explain it. So if all you can see is 180 degrees on a flat circle, practically, you're not able to see anything past this direction.
Let me ask you a quick question, real fast.
But that's what I was
Just
saying.
real
They claim
quick.
that Polaris is so far away that it's coming in parallel, and therefore that would pretty much. That's how they fix that problem. Like they have to put the light years. Or sorry, they have to put their stars light years away, and their celestial sphere, which they claim is like essentially treated as infinite. They have to do that in order to assume that Earth is a sphere.
On that diagram, let me say this real quick. On that diagram that you guys was looking at, where were they when they took those measurements? Like what state were they in? Were they in the United States? Where were they? It's an important question.
which ones?
Because the one that the diagram a while ago where you guys had all the angles and stuff on it. Where
the one Rixie was sharing?
Yeah. Where was that observation made? Where they got all those numbers and stuff? Did they do it from the United States? Was they like, yeah, that?
Oh wow!
Did
Somebody
they-
just brought it in.
All
Someone's
right,
being
now,
productive.
they
Who is
can-
that?
Yeah. But anyway, you can move it out of the way. All I was going to say is if that was in the United States, then that is up here. So this yellow line is not on the equator. It would be more up this way like that, making it much easier to see Polaris in the sky. It depends a lot on where you are on what Polaris is going to do in the sky. So if you're down here on
Alright,
the
just gotta
equator,
respond to Elmo's
obviously you're
question.
barely going to see it. Go ahead.
My response to
Elmo.
it is that it's because it's light years away. That it is, and because on a globe you wouldn't be able to see like something above the North Pole at a closer distance. Well, are you responding to that? Yeah, somebody just put a star there. Here, so if I zoom out on this even more for the screen share, okay, there. So yeah, Elbow. I guess this is how I'm saying they describe it. Somebody put the star up there.
Right.
For some reason, their avatar isn't loading. It's like, is it broken for you guys too? I can't see who that is. It has like a little like broken link thing in it. I thought that was someone's.
I see the star scrolling around, going around.
Anyways, yeah, okay, the star up there. Yeah, so go ahead. Or I don't know. I mean, were you responding to that?
No, go
Cole,
ahead.
or-
All I was trying to say is where he's got the yellow line at, that means they're standing on the equator. And I don't even know if you can see Polaris on the equator. So what? I thought you guys was talking about the diagram a while ago and was trying to match it up, saying this is why that diagram that somebody pulled up there and put on there. I thought y'all was saying this is why the angles are the way they are and stuff. But so I may have missed following what he was talking about when he. I was just saying that I don't even know if you can see Polaris from the equator.
Okay, so that
it
is
says it's visible.
That's where
Polaris
it
is
starts
visible
to
from the
disappear.
equator. Yeah, sorry, go ahead.
I mean, it's pretty difficult. You can technically see it a little north and south of the equator, and that's a whole thing that even the globe model claims that there can be refraction, is what they have to claim for it when you go south of it, because the geometry, Elbow. I mean, they claim the geometry as you get to the equator, you can no longer see Polaris once you go south of it. So that line that you're drawing there, like the orange one that's going like vertical, I guess like you'd have to somehow like angle that to be like, I guess on the globe kind of, theory, the globe model, you'd have to like angle it to where you're just going over the curvature and then Polaris is just barely visible at the equator. You know what I mean? So that orange line, like your sight would have to be whatever that angle is going down to the horizon.
Yeah, that's a ton of refraction. They're trying to say that it goes on that.
But also remember, I don't know if I've joined too late for this, but Polaris isn't dead center. So if it's 0.6 degrees radius of rotation, that means for part of the year it should be, ignoring refraction, should be 0.6 degrees above the horizon at some parts of the day.
Yeah, but my point is that any star, let me see if I could create a square.
I know what you're saying, Elbow. I know what you're saying.
Yeah, those, you shouldn't be able to see any of those things.
Here, Gio's answer was correct. So he gave the right globe answer, and you can. This is something you can calculate with geometry. So if you're standing, say, like let's take like 45 degrees latitude, so you're halfway from the North Pole to the equator, right? There's a height you could move Polaris down. There's a theoretical height where you couldn't see it anymore from 45 degrees north. But the fact that it is so far away makes it where you can see it. Right, so you could draw a man up there and then put the further away you move it, you're going to get more and more visibility along the surface. What I would say about Polaris visibility is when you're at the equator.
What you're trying to say is that we have unlimited vision, right? That's one, and then not only that, we can see around a flat surface, because pretty much what we see when we're looking at all the way around us is a flat surface, correct? Not proving flat Earth or anything like that, or you see a flat surface all the way around, a circle around.
Oh, it looks flat until then we can't see anything anymore.
After you can't see anything else. But what you're saying that all these stars that are on this side of that flat surface, you're able to see because it's far away? How are you seeing past the flat surface?
Did you see the Earth?
They'd be below the horizon. But now, I posted a picture of what I'm talking about. Now, this would be more like it. See the line at an angle? If that's where they were observing from, then it would be that they would be looking at Polaris, but Polaris would be higher in the sky. If you're on the equator, Polaris is plumb, like barely visible above the horizon.
You still see it. That's what I'm saying. That means you're seeing around the curve.
No, so you would only see stars if you was on the horizon right here where you would only see stars up here. These are the stars you would see up here. You wouldn't see none of these. These would all be below the horizon and set already. If you was standing here where you got these yellow lines and that's your little man right there, you'd only see these stars right here. Yeah, everything below that yellow line will be below the horizon.
And Polaris will seem like it's right here.
Yeah, but that's because it's so far away. It's like a triangle, right? If you imagine somebody standing on the North Pole is looking straight up at Polaris, you're at the equator, you're looking horizontal at Polaris. Those are a triangle, those lines, right? They are converging, but they are converging so incredibly far away that you can treat them as parallel and not make any mistakes, any meaningful mistakes. So it does in this diagram where Polaris is, 1,000 miles from the surface of the Earth, or probably about 8,000 miles from the surface of the Earth. What you're saying is absolutely right. It should be hidden. But as it gets further and further and further and further and further away, it gets less and less and less hidden.
Elbow, does this describe, hold on, if you want to respond to that, but does this describe what I just pulled in this image where kind of if you have like your azimuthal, like flat, it's flat locally, all that stuff, and then you got to put that on a globe somehow? Is that related to what you're saying?
Yeah, that's pretty much it. So you pretty much get to see just this circle somewhere, but just you can't cut off I mean, it has to. You're not able to see past that circle, past that circle of your view. Yep,
Why
that's
can't you
exactly.
see?
Just
Why
imagine
can't
though,
you stand here and look straight up this way?
You could, but he's talking about if you put that dome all the way down to the equator. We could even maybe rotate this image to kind of somewhat simulate it. However, you do the Earth, the image rotation in the software. But oh, here we go. There. Oh wait, we were both doing it.
Yeah,
someone was doing
it. Yeah, we were fighting for it. Go ahead.
going with it.
I think like 3 people were doing it. I don't even know if I grabbed it. Right, someone. All right, they put the equator on the right side. All right, fair enough. Yeah, so if you have that and you have 180 degrees, it's not like you have more than 180 degree. This gets back to the whole like, is there curvature argument as well? But I mean that, if the ground is a flat plane, it would at the equator it would be shooting off into space. It wouldn't and that's where they have to bring in that the light is coming from Polaris,
parallel.
so far away that parallel, right? So that's why that's what I was saying.
And here's the
not
thing,
only parallel, but also refracting.
Here's the thing about just like when we look at the sun and it looks small. If since Polaris is a star and it's bigger than the Earth, that means that the light coming off one side of Polaris and the light coming off the other side of Polaris is far wider than our entire planet. So the light you wouldn't just draw one little tiny light beam straight down into the North Pole and say that's the light from Polaris. You would also need to draw a straight line down, slicing right down the side, just like his yellow lines, because the same light comes in straight down there from Polaris as it does straight over the North Pole down from Polaris, because Polaris is larger than the Earth. That means light comes in on all sides and it comes in parallel.
You said
even though it's
Polaris
that
is
far
larger
away.
than the Earth?
Yes.
Well, it has to be in their model. Everything away from Earth.
Yeah, all
has
this
to
is
be
in
way
the globe
bigger
model,
than Earth.
obviously. That's what I'm talking about. I'm just arguing for it right now. I'm not trying to say it's absolutely right or wrong. I'm just arguing for the point.
Yeah, no, I understand. I understand you.
I was trying to put a line that goes kind of off that, and then that it would be like, yeah, it wouldn't be at an angle enough. Yeah, it's for the if Polaris was local on a globe, if it was like close and local, that'd be an issue.
Yeah, if you imagine the base, if you imagine isosceles triangle, the taller it gets, the closer to parallel the sides get.
Hey, Eggs, do you see my new avatar?
No.
Can you tell what
Let
that
me
is?
see it. Let me see
Can
it.
you tell what that is in my visor?
I can't tell. It definitely looks like Earth.
So
is it one of the Artemis photos?
Yeah.
With a visor that's.
It's when they took
It's
one
like
for the dark side of the Earth.
It's going to be it's going to be the Nazi base on the backside of the moon is like glowing cities. Is that what it's meant to be?
No.
No, I think it's just the Artemis photo when the Earth was dark.
Yeah.
Right.
When I put it on there, it's dark, but I just left it.
So
Elbow, your point on this, because you jumped in when I said that we see half the sky. Your point was more that you don't think we would be able to see half the sky based on your kind of take on the geometry of it.
Sorry,
because I think it's pretty well established that everybody sees half the stars at one time.
Yeah, no, it isn't. Actually, if you look it up, it actually isn't.
I mean, let's say within 1 to 2%.
No, it's way lower than that.
Is it? What percent is it? What did you hear?
Wait, what is this percentage that we're waiting on?
Like what percent of the total stars in the sky does any one person see at a time? I'm contending that it's roughly half.
No, that means that when you see 180 degrees, you see half of the Earth. That's practically what you're trying to say.
No.
Yes, in order for you to see half of the sky, that means you will have to see 180 degrees will be from pole to pole.
Yeah, but like to see what's in the sky, I don't have to be able to see the ground. You could demonstrate this pretty easily with just a ball, and you could then place different things above the ball at different heights and observe that I could see something above a point on Earth without being able to see that point that it is above. Like imagine you're holding a basketball and you tilt it away from you, so I can't see the logo on the basketball. But I'm going to stick a like a little pole right there, and I'm just going to raise it up. At some point, I'm going to be able to see the end of that pole, even though I can't see the logo still. That's my point.
To be way higher. In other words, for you to be able to see.
Yeah, it would. I agree with that.
At least 200. Yeah.
There we go.
Who's going with?
Dude, who pulls those? Somebody's so fast. It's impressive.
And also,
my claim wasn't a geometric claim about the globe. I'm just saying, I think that's like, we know what stars are in the sky. We've studied it, and we know what the total set of stars is, and people see half of those at any given point in time.
Have I never heard you speak before, Pfinky, or have you got a great new mic? Because your voice is lovely.
I've been taking voice lessons for how to talk better. That's probably what it is.
You've been trying to talk more good?
Yeah. Yep.
Trying to do better with the talkings? No, do you have a new mic? It does maybe sound better than maybe in the past.
No, I did. I have the same mic, but I did. I'm running it through main stage. I've been experimenting with doing that, like setting it through main stage into like black hole to get rid of, like, do my own noise reduction pre-processing. So maybe it does sound different.
Yeah, I wonder if I have the crisp thing on. I always wonder if the crisp like makes my quality. I think sometimes if I have my mic open while someone else does, like it might feed back a little bit. Because I just remind me, because you were talking about noise reduction, and like it would be better to have a more custom option. That's what it made me think of when you said that, rather than just using the crisp thing. But I think if I turn crisp off, like here, I'll do it. You guys can tell me. All right, now I just turned it off. We'll see if it echoes and stuff, but does it sound any different?
I mean, to me, you sound better with it on. And not like because there's noise, you just sound better.
Interesting. Okay, so back to like one of the other things we were talking about. If we have no more to say on it, we don't have to necessarily. But what led to this originally, and if we have more on this, we can stay on this. But was basically like how the celestial sphere shows up in terms of the geometry and those different factors of like where the 6210 is. Because like, yeah, on the globe, they claim that 6210 is like from the equator to the North Pole on the ground, basically the ground arc distance. But if you have the objects in the sky functioning like 3959, and then as you move away from them, they maintain that. They maintain that. But then that makes the arc of the sky the 6210 on like a planar stationary Earth. So they basically would have just taken like the hemisphere that we're in and then turned that into being on a sphere and then made the stars light years away to account for the way the stars actually function on a more local flat plane versus what it would be on from the globe. As I'm saying, that's what I guess you have to call it a hypothesis, because the globe model is the mainstream now, even though for all of time, the globe would be a hypothesis in the first place for people to come along and say, hey, we live on a globe. It's funny that now we have to call a stationary planar Earth a hypothesis, although you don't have to call it that, but I'm just saying, like, because it's not the mainstream, as it were, meaning like something different than what the mainstream is claiming as to how the sky works, because that's what we were talking about before, is how Polaris drops and then the 1 degree per 69 miles, because that does work over a plane with those two geometries, the 3959 position that lowers as you move, and then the 6210 arc length distance from the horizon up to your zenith.
Well, I still say it doesn't work without an extra ad hoc explanation. Like you have to create, because you keep describing like a plane above another plane, but like the graphic you showed of Shane's shows an actual curve. which would represent something that's not in reality. It's a thing that requires explanation. So I feel like
I think Shane did. Well, the one animation I posted, I think Shane did make that one, as far as I know. Or either he made it or he had grabbed it from something. But yeah, that one is just an animation of the celestial sphere. Yeah, but that's not really. I mean, that's just Shane did make the animation, but that's not unique to what has always been considered. That's why planetarium is made in a hemisphere. Planetariums to represent how we see the sky. So I mean, you have an azimuthal grid. But I hear what you're saying. Like the animation that Shane posted does show, but even that other image I posted, like this one, which I'll post it again. But I mean, this one shows a hemisphere as well. Shane's just shows it as an animation, like in a kind of hemispherical dome. Like here, I'll just post both of them again so people know what we're talking about. I think that second one is the animation Shane made. So yeah, and Shane shows the distances, like the 3959 of the actual celestial sphere. The 6210 is the arc length distance from the horizon up to the zenith. And that's what they're claiming. So like that animation is kind of cool because if you put yourself on a flat plane in the middle of that, you get that hemispherical effect of a sphere above you. But if you then wrap it around underneath the earth, just hypothetically, even though no one's really claiming anything's going below the ground, but if you just hypothetically, meaning you complete the sphere, then you actually have a whole sphere instead of a hemisphere, even though, et cetera. And then that's basically what they claim the globe is. Because see how it shows the radius from the center of it, from the observer in the middle, like on a flat plane, that radius is 3959. Well, that's the radius they claim the globe is. So basically the thing that surrounds us, they're claiming is the Earth in a way, because all the geometry, and then that 6210 from the equator up to the North Pole on the globe model, like actually from the equator physically on the ground to the North Pole, that's the 6210 ground distance, which is on this equal to, like I keep saying, the arc length of the sky going from the horizon up to your zenith. So that's where the 6210 actually is. But it still matches, it seems, to 6210 distance because, you do have that's the distance from the equator to the North Pole. The question is that actually happening on the arc length of outside of a sphere, or is that actually the way the sky functions as you're moving away that same distance over a planar surface, the 6210 equator to North Pole distance?
Yeah, and I think I said it earlier, but my issue with this is it requires an extra explanation. Nobody knows why on flat Earth this sort of a thing would happen, right? Because if you just make the assumptions of the sun moves in a straight linear path, the angles, like I posted it again at 25 after the hour, but you could move the sun, 6,000 miles away. The lowest it's going to get is 25 degrees in the sky. So flat Earth needs some explanation of how you can get it from that 25 degrees to go down below, to the horizon and below.
Well, what, you're just assuming it's like a ball up there? Because I mean, dude, the ancients, like the thing is, the ancients since the dawn of time had planar Earth cosmologies, and they had no conflict about the stars. Now I realize it's a whole different type of argument if I was to actually put it forth as an argument, because then we have to validate, well, who are these ancients? What, and then be able to confirm it. But I guess what I'm saying is that even in the mainstream kind of life of today, even of what the history they do claim, as well, like humans have had a planar Earth, cosmology since the dawn of time. And they were very advanced in astronomy and able to make ephemerises, like ancient ephemerises and stuff. So they knew where all these things were. So there's no conflict on a planar surface. It's, well,
you could say, ancients could say a god makes the sky move at 15 degrees per hour. And this isn't how we see things on the Earth. It's different. And it's that way because God made it. The globe doesn't have to do that. The globe can just use normal perspective and Earth curve, and then everything works. The reason why we see half the stars at any given point in time works, right? Everything else works. We don't have this extra thing that we have to inject.
Oh, I don't agree. What is an extra thing on a planar surface? You don't need any extra thing. For eons of time, people had a planar
why the
Earth.
stars move at 15 degrees per hour.
Oh, why the sky is moving? That's what you're saying? Because I mean, if you're going to go
specifically why it doesn't follow the laws of perspective.
Okay, well, that's ultimately going to be the dynamics of the sky, because the kinematics are just kind of where we're observing the positionings. Kinematics would be more related to the ephemeris, like just the actual empirical observable position of them versus the dynamics of what's actually like making them move and what is actually forming it and how it's moving. Okay, well, I mean, for that, like for the motion, yeah, and anyone who was just born here, like you would have, I mean, the whole world seems to be put before you, and one of the features of that is that the sky moves. So yeah, whether you're going to call that a god or whatever it is, it's obviously part of like nature or how this realm seems to function. And then the globe says, well, we're actually on a ball. But even if you go with that, I mean, the Big Bang, I don't know. You said a lot there because you're kind of saying like, there's a few different arguments in there. I'm trying to figure out where you're going with it.
The main crux of my argument is that I think the globe has a much simpler model that requires less extra things to be explained.
Oh,
like,
so
we
okay,
don't need
let's say
likes it.
Let's say there's two babies who are brand new little baby guys, and let's just say they've always been on an island and they haven't been out much. They're just literally, and then eventually they get old enough, but they don't believe anything about what the Earth is. Now I know there's a whole thing. If you asked them, they both would probably say, well, the ground is stationary, the sky is moving, that kind of stuff. But I'm not really going there with it. I'm just saying if you were to then tell them, well, hey, the explanation for how the sky moves is XYZ, we're on a planar surface, perhaps it's ether, an electrical field, or whether you gave them theories or ideas, but there's obviously motion involved. I mean, the wind blows, lightning strikes, lots of things happen. What is the explanation for all these things? And the sky moving is one of those things, just like, animals reproduce and all kinds of stuff just is happening before us. So the sky moving is one of those things you'd have to explain. But I hear what you're saying, because what the globe does is says, well, hey, you see the sky thing, but actually that's all because you're on a ball, actually, and you're on a ball and it's this size, and then it's rotating, and then the sky is actually really, really far away. It's not just like local. So you have to explain it to like I said, two little babies that grew up, and then you just, by the time they were 10 years old, they didn't, then you just told them these two ideas or whatever. I think it could be argued that they both would have a default ground not moving, sky moving, default. But nonetheless, if you told them these two theories, but I don't agree with you that the planar Earth would. I mean, what do you mean by that? Because, I mean, the globe has all kinds of issues that would have to be brought in. You'd have to then tell that child, well, there's a thing called gravity, but we don't quite know what it is, but it just does these things. And then, we don't really know how we got into this huge vacuum. There's this Big Bang idea. And then and then there's the dark matter issue and the CMB and all kinds of other facets that we could get into the whole wellspring of things with the globe. But I guess, where are you coming from into, like, what are you saying you think is explained differently on either model? Like, what's the thing that you think is some extra thing you're saying with the planar? So what is that extra thing?
I'm limiting it to what we see, the explanation for why we see the skies move, why we see sunset, why stars, why we have seasonal stars, right? I'm not like getting into gravity and all that, but just if you just say, oh, it's a globe, because if they were on this island and then they went 1,000 miles away, they'd be like, well, I've studied the stars every day, and then all of a sudden they're going to realize, well, shoot, these stars are different than what I saw. Why is that the case?
That worked before the globe model, man. You can throw a globe in and make it work, which is like shows you how to make anything work and shows you it worked before the globe.
Well, I think stars. You can make stars work at any one point. Like so ancient civilizations that were landlocked, they did have star models, but I think once you expand to the whole globe and you see where everybody on the globe sees stars, then it doesn't work so well.
We're on the ocean, bro. They were on the ocean.
Yeah, but dude, the thing we're talking about. Go ahead.
No, I'm done. Thanks. Yeah, go ahead. Someone else was.
Okay. Yeah, I just couldn't hear if I interrupted you or not. But
my response to that would just be that by the time we were sailing between continents, we weren't going on the assumption of a flat Earth anymore. We'd moved past that to globe. I mean, there may be some ancient civilization, but
so local.
Well, I mean, I would argue that it's a much more complex explanation to try to explain it, that you're on a ball. I mean, so I just drew, like, somebody put this globe in here on the whiteboard thing. I just put like a green line through the middle of it. So, I mean, the thing that the contention we're referring to is that, and I put a little heart in the middle of it. So let's say the little heart is like the dude there, right? That's like right here. That's like the person. Now, if you're on a planar surface and that little heart is like where you're seeing from, your observer, you have this like hemisphere, you have like this hemisphere effect that we see. And there's never been any conflict through all of time with representing that hemispherical region of the sky over a flat surface. Like that's never been any conflict. And in fact, in terms of celestial navigation and all the like ancient astronomy that we at least are told of, and so on, and the way that they lined up, like things like pyramids and all these things with these celestial bodies. I mean, a sundial works with like a flat surface, and then you have a hemispherical region around it, basically, and then the sundial makes an angle. So I mean, that's just, and then all the ancient concepts of like, the sort of the dome, firmament, all these different components. So the thing is yes, that thing would have to be moving though. The sky would have to be in motion because the ground not being in motion. But I mean, if you then someone comes along and says, well, hey, actually, the reason for that motion and the reason for that is because we're actually on a ball. There are going to be some interchangeable geometries if you're going to make the ball 3959, but are you trying to make an argument that there's something exclusive about a globe that somehow humanity didn't figure out for thousands of years until just happens to be that these Greco-Roman dudes that are like a lot of the core of the modern day kind of education system and all this stuff, the Greco-Roman guys, first just popped in their head that they saw boats over a curve and put sticks in the ground, and that humans like all the time of mapping the stars and living on the earth somehow just didn't know this exclusive evidence for how the sky is a globe?
Sure. That's exactly what you would predict, right? People with the worst equipment are going to get the worst answers, and people with the better equipment are going to get better answers. Like that would be true of virtually anything, right? Our understanding of whether humans can fly, our ability to map entire continents, right? We're talking about people that didn't have accurate maps of their own tiny patch of the Earth and are blissfully unaware of other continents' existence. Yes, I expect them to have the worst model of the Earth.
And I would say there's still things today that Flat Earth struggles to explain, like why people look different. Any Flat Earth map you can pull up, and we can point out that people would look different directions to see the same thing in the sky.
But why isn't
easily
there
explained on a globe? But there's no like.
Why isn't a globe map? Why don't we have a globe, a clean, seamless globe?
We do.
You can't flatten a globe out, but there is Google Earth.
I mean,
and it works
if you
perfectly
spherically, right?
Yeah, but what is the thing,
presents
Pfinky,
it spherically now, and it doesn't have any distortions. So
well,
exactly
okay, so
as you're saying is a good question. What he was saying is a good question, which is why? Because if it's a globe, we should, and we know it that well, we should be able to map it very, very accurately. And the answer is that's a great point, and that's why we're so confident it's a globe, because when we map it spherically, we get a really good map.
But it doesn't work if you map it spherically, and this is why. Let me say why.
What
okay,
doesn't?
so let me just go like 30 seconds uninterrupted, and then I'll pass the mic. Let me just try to lay this out. So in Stellarium, or any planetarium software, etc., you have an azimuthal grid, which is a flat grid, essentially a circle, and then you have this hemispherical region that you see the sky, and the sky obviously is moving and doing all that stuff. Now that azimuthal grid is of one, let's say, latitude and longitude. And that's equal to what they call right ascension and declination, which are essentially the lat long of the sky. So you have your lat long of the sky, right ascension, declination, and then your lat long on the ground. And those match, 1 for 1, let's say, at the moment. So if you're at a particular latitude, which we can decipher from the angle to Polaris and so on and so forth. So if you're at a particular latitude and you're seeing this hemispherical region of the sky with the azimuthal flat grid, then if you move it to another position, same thing, flat grid, hemispherical sky, move it to another position, flat grid, hemispherical sky. Well, all those flat grids are flat. And if you put them all together, meaning every observable planetarium location that you could, it's a bunch of flat azimuthal grids. So that's why the stars do map over a flat surface. To add it, to put it into a globe model, they do try to say the stars are infinitely far away, but and they do have a way of trying to map the GPs, but how many flat azimuthal grids do you need to fit on a curved surface? It actually is a mismatch for the globe ultimately.
But that's just saying if we look at planetariums that obviously are going to have flat floors for the simplicity of getting around the place, I'm going to therefore assume that reality matches the planetariums which are constructed false reality.
Well, but
And
it's how
this...
Stellarium is built. Like it has an azimuthal grid on Stellarium. That's how Stellarium is. Like outside of whether a physical floor in a planetarium, Stellarium itself. That's why Walter Bislin, when he transferred the Stellarium data to make his model, that thing that he made, it's all the Stellarium data and it's on a hemisphere with a flat plane, and you can move it. That's why you can move it all around that little AE map thing.
What I'm getting at is this is reification, right? It's mistaking the model and a way of modeling it as in some way influencing or dictating reality. Whereas the easiest way to map it, right, the most effective way to map it is a sphere inside a sphere. It's just that for an observer, we never observe the sphere. We're always stuck standing on the top of it. So if you then map that in Stellarium, that will be a better representation. But it doesn't mean that the floor's flat, right? The floor's just a point. You just create a plane out of that by creating a horizontal
sure, but then
tangent plane, right?
The optics on water and whatnot, and so.
Say again?
Like in a planetarium, if you walked to stand underneath another star, in reality, the whole ceiling should shift with you. So it's not like quite a 1-to-1 representation.
It's very true, actually. The perspective shift would be huge.
Bob, the science guy.
It's a local 1-point perspective in the center of the planetarium, ultimately.
Yeah, that's why the best seat's in the middle.
The grid that goes around you is what all the GPs are mapped to.
Bob, the science guy.
It's a flat azimuthal grid. The only way they make up for it in the globe is to say the stars are light years away. So they invoke the planar geometry by making parallel light rays to then invert it to allow the GPs to work on a hypothetical sphere.
I would push back on one point. It's not flat. Like Stellarium's not flat. It's point based. Like when you're at a location, you're not on a flat anything. You're just at one exact point.
So Bob, like I was saying, Bob, he built a nice telescope. Bob, the science guy, he built a nice telescope, got the big cover over it and everything, and it's hooked to his computer, and he uses Stellarium. And on Stellarium, he just finds the star in the night sky that he wants to look at, clicks on Stellarium, and it tells his satellite outside in his yard to point at that star. So it matches what we see in the sky in reality so good that you can literally link a telescope, not a satellite, a telescope to it, and it'll point at the star you're looking at because that's exactly what's over our heads. And it's built like a sphere in the system. So I mean, it has to be fairly correct. He live streams it all the time.
So when you say it's correct, does it do any transformations when it's trying to sort of, what is it, between him selecting a star and it moving its cogs in order to point at the star, and whatever that is?
Yeah, basically, the way he shows it is when he's looking for a star to look at. It shows what stars he should be able to see because it shows the globe, and you can spin it around and then zoom into the point where you would be, and then it shows what stars are in a big sphere overhead around you that you should see, and it's a sphere, and you find that the stars you want to see. Well, when he picks the star he wants to look at and he clicks on it, the satellite or the telescope outside is basically oriented exactly like it's oriented in Stellaris, and it points in that direction, and
That's one of the
dead on
ones.
accurate.
Yeah, it's one of the stronger ones, I think, in that if you want a gut feel for what this turning looks like and what these angles mean, is any of those time lapse of either where it locks on the stars and you get this idea of like the planet turning under the stars, or you get something where a telescope has locked on a star and you've time lapsed the telescope moving, and exactly what you're saying, Cole, you see, which is down near the closer you get to the poles, the closer it is to doing a horizontal loop, and the closer you get to the equator, the more it's like doing a vertical loop. You're like, okay, it's just suddenly you get a gut feeling for what it's like to be on a ball.
I don't know, Raqia. I don't know if it does anything, like changes anything.
You might want to check your gut.
Might want to check my gut.
So what do you call it? The flora.
I mean,
My
I'm
gut
assuming
makes it feel like I'm turning, even though I'm not. Or
I
makes it
think
feel like
typically
I'm
the
not
star
turning, even though I am.
positions are in like geocentric coordinates. So to get to convert his satellite, you'd have to get the lat long converted into, for what they call like horizon coordinates. But outside of that, I don't think there's anything else. This is where Shane would say it's all a coordinate system.
Yeah, I kept saying satellite. I meant telescope. He built a big telescope in his yard.
And I think it is a coordinate system. It's just that transforms show, if you try to do a transform from sphere to flat, it becomes clear how.
So Columbus had a navigator.
Yeah.
And who was he? I can't give you all the answers here. I'm just kind of thinking about but yeah, I mean,
real quick.
Go ahead.
But hang on, let him finish his point about Columbus's navigator.
Yep.
I'm interested in that one.
Well,
he
yeah,
he couldn't get it out, dude.
Yeah.
Yeah.
True. Go for it, Oz. Okay, go. Not that I'm moderating. I don't know why I've decided that I'm in charge of who gets to speak. Go for it, Lion.
I forgot my name.
So if you heard Geo, it's Stellarium. You have an azimuth of grid of vision, which basically is the flat Earth. You could do the same thing. It's called the equatorial mount, right? Where computerized mount that automatically locks on a star or a planet or a galaxy. All you do is type in you type in a couple numbers, and the thing automatically locks onto it. That's
his
that's
is not,
you could.
His is not an equatorial mount though. Equatorial mount's different.
But what do you think's happening, Lion, when that equatorial mount points down and does a big circle at the ground?
His
Well,
is
I'm trying to explain to you.
observation.
It just depends on the coordinate system. You can use an azimuth or grid of vision and do the same exact thing, and that's evidence for flat Earth. The thing is with the azimuth or grid, it's like having an astrolabe. So you have if you
Reading
have
the
a
sky
globe,
a certain
right?
way doesn't dictate the shape of the ground.
An equatorial
if you
mount won't work on a flat Earth.
hold on, dude. Yes, it will. Listen to me, dude. If you have an azimuthal grid of vision, right? That's basically an astrolabe. That's what the ancients used to navigate. All you need is to have individual astrolabes for your geographic location, because there's a limit to your vision. That's why things get obscured over the horizon, right? So on the flat Earth model, the reason that things become obscured or you have this declination of the stars isn't because we're on a globe. It's because there's a limit of vision. So you need an individual astrolabe. You need like 12 of them to put the whole Earth together.
Well, what is the limit to your vision? That's worth exploring. Because if that's true, I think flat Earth wins, where we think we can see forever. So we don't understand that at a certain point, something is happening with our vision that is, I think, central to your claim. And I think that's right. I think if light starts to bend or slow down or speed up or do literally anything, we might be massively wrong about the scales of our universe and all sorts of things. Yep. What is that limit to our vision?
And I just want to inject a question, if you don't mind, which is what, like when you reach the end of that limit, what happens? Do you just stop seeing things? Do things move around where you see them? I'd love to hear that.
Because of perspective and the atmosphere conditions, right? The closer that you move, or the closer that you are
but
to an object,
we're not talking about perspective and atmosphere. We're just saying just the limit of vision. Just explain just that part of it, like what that
Well,
does.
that's why we have a limit of vision, right? The circular, right? There's a circle all around us. That's the in the astrolabe or on stellarium, the sky, the hemispherical dome. The reason that you have a hemispherical dome is because of limit of vision. You can only see so far.
That's fine, but just tell us, like, things like where is it, what causes it, what's it made of, what's the function, what's like literally I get that you're saying it's there, and I'm there with you, because if I think you're right, if it's there, the globe's got a lot of problems, because then the movement of the stars is not necessarily a great way to determine what the ground's doing. You could end up with local suns and moons, and that could change the shape of the Earth. It could change the shape of our sky such that we'd have to reassess the shape of the Earth. But what's causing it? Where is it? What's it? What is it? I don't want to just hear it's there. We all of us know that you think it's there, but I want to hear a bit about how it works. Like I've heard some people say superfluid, and I'm like, that's interesting because then you could have a change in density, but something about it is very, very low friction. So you can't quite tell, despite the fact it's bending light. You could still send spacecraft or things up into it. So maybe it could be. But what is it? Where's our vision changing? Because if I see something, part of the confusion I have about the black swan and stuff is if I see a black swan, I go, that's where that fucking oil rig is. Right? And what the globe is trying to tell you is like, no, your vision's actually a little bit funky like that, and it bends around a curve. And then you rightly go, how? Where? When? According to what principles? And we go, great, here's the work. Here's how it bends just a little bit down near the water. Where's the limit of vision? What's causing it?
If you see
is light
something,
photons?
Except, wow.
Yeah, so I have no service, dude. It's the radius of the Earth, 3969.
Wow, that's remarkable, that coincidence. So I cannot see anything more so the moon and the sun must be closer than 3959.
But wait, hold on, because earlier Geo said it was 1/4 circumference. So 62, whatever that is, 6210. You're saying it's only 3959, Lion?
That's wait, he broke up. He broke up for me. Did he break up for you guys?
Yeah, he was chopping in and out. He sounded like he was driving again.
I don't have service, dude. I got to back up.
Well, you're good right now, but just that one little part. You only cut out for like 2 seconds, but it was the part. But it sounded like you guys heard him, so that's why I was like, "What?"
Yeah, he said the limit we can only see 33,959 miles.
Yeah,
which that's a lot less than.
No, I mean that was the what we were talking about earlier. And that animation and that's what like that animation that I think Shane made shows up 3959 that we were looking at earlier. But yeah, you could see in a
I thought it was 6,000 something.
Well, that's the overland distance. So the radius. So that this is a problem. For
that's the overland. That's the arc. It's either the arc of the sky, the 6210, over the planar surface, or the globe would call it the arc from the equator to the actual North Pole of a sphere. That's where they use the 6210. So it's either of the sky or the ground, basically. Go ahead.
Yeah, in Shane's is 6210. That's how high up. That's how far you can see.
So no.
I'm sorry. No. I'm sorry. No. I'm sorry. I'm incorrect.
Go ahead and get that right.
This is the animation.
Yeah, I just scrolled up to it. It's I read the top part. I didn't notice that he was showing the arc.
Yeah, but Lion, you don't have connection, or what was the last point that Lion was making, or that you guys were on?
So he was saying there's a limit to the vision, and I was asking why, and he said it's at 3959, which I think is good, but it's a remarkable coincidence. That's very interesting that it relates somehow to the length of the equator, is what I would say to that.
Right. Well,
How do we know that's how far? That's the limit to how far we can see.
Yeah, and that's interesting because that's a hard limit. It's not like a asymptote that it gets closer and closer to zero as you approach 3959. That is like 3958, it's 100%, and 3960, it's gone. Right?
Yeah.
That's a binary. So that's fascinating. So something really crisp happens at a very clear distance from us. Great. That should be like a fishbowl, right? That should be like a hunk of glass if light does something weird at. That's interesting.
What about that it functions like a 3959 lens?
Okay, I like it. So a lens that creates a termination point at 3959, but it might scale towards that or something?
But it'd have to be a personal lens, right? It'd have to be a lens for each person separately.
And a lens for even if it's not a person, right? Because I could leave a camera on any patch of dust or water on Earth and it would capture what it must. So it's not, it is lensed regardless of whether people are there in case they were.
Like the double slit.
Yeah. You're saying the sky still appears that way to like a camera. If you put a camera out in the middle of the desert or something, or it's like...
Yeah, or a camel. The camel must see the same stars, so it's not particular, a tree must get shade from the same angles.
That's why sometimes when people talk, right, that's why when people talk about like, oh, all these things are in all these apparent positions, like to go really, I'm not saying there's not that effect or that's not a thing, but like the angles coming from the sun are they're not just, as you like to say, wibbling around, your word wibbling. The shadows are not like, it's not like the sun is in some apparent like hopping all around thing. Like it's very consistent, like a sundial, and you can just see like the shadows, the edge of your house.
We feel heat from it. The sun's unique because we can feel heat and detect radiation from it.
Yeah, that's
but the thing is, we were looking at before at gleams, like the 1 degree per 69 miles within that like XYZ, and like Gleam put Polaris at 3959 apparent altitude when you start, and then as you do the 1 degree per 69 over a planar surface, that 3959, meaning the apparent altitude, really it's just like apparent altitude. So like that Polaris, we see it where it is, and then it appears to be lowering. The thing is, we have no way, like I was saying before, to like go physically touch it or validate it to know what where it is, what it is, how it's appearing there. Like how is it appearing there? Is it? I mean, the heliocentric model is going to claim a ball of burning gases out light years away, and it's massive in size. And some of these stars are claimed to be trillions the size of the Earth. So I mean, they're going to go with that. There's like sonoluminescent ideas or theories that's like using sonoluminescence, where you have a sound in a bubble, a sound wave in an air bubble, which essentially emits light. So you can go, I mean, there's those kinds of ideas. There's like, maybe superfluid or electrostatics, theories or other ideas like that. But I mean, why is it appearing there in the first place? Like if it's not something that we can confirm the altitude or the physicality or where it even is, we're just seeing it at an angle, basically, to where you are on the ground. But anyways, if you make that 3959, like if you want to just say hypothetically, and then as you do the 1 degree per 69, as Polaris is dropping, the apparent altitude goes from 3959 all the way down to 0, then that seems to be the ratio of this realm that seems to work. And I've always thought 3959 is like integrated into this realm, but that's the question, like, is that number actually the radius of being on a sphere, or is it a feature of the sky, or like we're talking, that's why I said like a 3959 lens is kind of one way to think of it, or that I thought of it there.
What else about that number? Like prime or anything?
It's probably worth
is it
mentioning
prime
too
of
that
something? Because I argue this, right? The number that Geo said is the quarter of the circumference of the Earth. So flat Earth has this problem, and I really like raising this one. I'm glad you did, Geo. Is flat Earth has to decide when it creates the equator and it's flat, it has an arc length that is going around a ball to get to from the North Pole to the equator, or any portion of that, a quarter of a circle. But because it's a quarter of a circle, of a full circle around, that means if it's a straight line, pi equals 2. So it's not actually a radius, it's a arc length. And so if the way you do it is this: if you look at the A map and you go, where do they put the equator? Because when most people try to do the proportions on a flat Earth to do any measurements, you end up going, how do I decide what X is? And then you go, I know the length of the equator. So most people fix the length of the equator, which is roughly 24,000 miles, which is correct. Equator is roughly 24,000 miles. So you can see things like the GP of the sun whizzes overhead at about 1,000 miles an hour, and it does it about 24 hours in a day, which means 24,000 miles. Great, so it works. So we know we've got the equator right. And then you keep fanning out from there, and people in the past have pointed, Australia's so stretched and long, it's 6,000 kilometres across where it should be 4,000 kilometres across. Don't you think Australians would notice that Perth was like thousands of kilometres further than it's meant to be, 2,000 kilometres too far? But here's the problem. I know I'm going on, but I think I can make this make sense for people. If instead of preserving the length of the equator as 24,000 miles, if you choose to do what Geo's saying, which is preserve the north-south distance. So if you drive from the North Pole and you get to the equator in Ecuador, you should have travelled either 3959 miles for the correct radius of the equator, or the overland distance, which is Geo is saying is 6,212 or something like that, or 6,012, but it's much, much longer. So if you preserve that distance, you have to now make the equator far, 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 far bigger, such that the sun should be going overhead at like 1,800 miles an hour, I think, if I'm right. So it should overhead, because it's got to do such a bigger loop in 24 hours. So there's a big question that Flat Earth has to answer, which is essentially the globe must have either the overland distance from the North Pole to the equator wrong, or it's got the length of the equator wrong, and flat Earth could unlock that maths.
Or the equator is not a circle around Polaris. Or the equator is not a circle around Polaris. That's another option.
Well, I think so circle is pretty strong because it's a circuit. So we know that the sun passes back over the same point at equinox. We know that we can fly around it. We know quite a bit about the equator. And if you look at it from anywhere on it, if you look at it from anywhere on it, it's a straight line. But if you move either side of it, it becomes a curved arc. And that's definitionally what a circle must do. So the chance that it's a circle is nearly 100%. Because it's a line on the ground, right? It is conceptual, but it is a definitional line on the ground that if I said it's in Sydney, you could say, no, it's not.
Yeah, but a straight line, when the sun is on the equator on the equinox, it makes a straight path upon the ground. How many straight paths make up a circle?
Exactly. Unless you're standing in the middle of a whole loop, and then it looks like a straight line. But it goes over your field of view. It goes from over the top of your head to down between your legs.
No, but my whole thing, I was just saying, okay, so if you have, right, so on the globe model, they have the 3959 as the radius from the middle of the sphere to the outer edge of the sphere. And then the 6210 is the arc length distance from the equator to the North Pole on the ground. And like you said, I mean, you could actually validate that. Like, you could go to the equator and literally drive. I think the highest you can go is like 80 degrees north. Like that's like in a civilian travel without maybe having some other type of thing going on. But like, so can you drive to that 80-degree north city? I don't know. You might have to take some ferries or whatever it is. But I've been just saying you could try to confirm the distance from the equator to the North Pole, or at least to 80 degrees, which would get you most of the way. Perhaps by either driving it or somehow confirming it. But yeah, so if you
you would have to notice if there was, I'll just jump in and then throw immediately back to you. And you would also notice if there was, you can't bunch up all of the missing miles in the north because we know it's an even relationship. So if the distance overland is meant to be roughly 4,000 miles, but it's in fact a smidge over 6,000 miles, that's huge. That 2,000 miles is different, but that 2,000 miles must be hidden within every mile. You can't just go, oh, it's all at the last 80 or 90. So it'd be very clear if that would change the length of North America quite a bit. And it would mean you don't really know the difference between, say, LA and San Francisco. You've got that wrong by a fair chunk, like 1/3.
Could it all be crammed into the last 10 degrees? Yeah, that would be kind of wild. I mean, I guess not, unless the sky is like, you brought in some other like warping or some wild other effect. Or something.
This is just physical overland distance. We don't need anything for the sky fix.
You could also get to trippy ideas of like a black hole-like effect that starts to happen near the center of the Earth, where like time and space warp. I'm using global idea, kind of words there, but they don't really own the word time, space, or black hole, but like a portal.
But that would be like a circle.
Time and space warping. But I'm not trying to really go there. That's a whole nother. I'm just saying if it was all crammed in the last 10 degrees and somehow there's like 2,000 miles crammed into what really should only be like 800, 600 miles.
You can see that it's not. You can see that that's not the case because, for example, around.
But you'd have to fly
the
over
circles
the North
around,
Pole.
so you know how far east, west, Helsinki and these places up in the northern reaches. They know how far the next city is over to the right. So they know how small an Arctic circle they're on. They know that the radius of their circle is far smaller because they can feel the curve of it. You can see that to get to that next place, you're driving in a curved path because the circle's getting smaller and easier to notice where it's a straight line at the equator. And so we can't fit more in at the end because otherwise each successive circle would have a different radius value, right? As you draw a new circle through, it's a weird way of describing it. It's essentially what we're trying to figure out is how can we have a circle with a non-linear radius? So radius should be a straight line, shortest distance between 2 points, but it is for some reason curving or bending, maybe up in the northern reaches to fit in more radius.
All right. Well, outside of the idea of like more area being fit into some kind of like other physical conceptual thing, like outside of that, if we just what you were saying about the 6210 number and how that doesn't fit with like a flat radius of 39, because like on the AE map, if you maintain, like you were saying, the 24,901 equator on an AE Gleason's map, if you maintain that, the distance to the North Pole would only be 3,959 miles. But the claim is that the distance is actually 6210. And on the globe model, they account for that 6210 from the North Pole to the equator on the ground. If you were to travel on the Earth, like that arc length, as it were, is the 6210, which you were describing. And then, yes, that is a whole thing for the Gleason's map. Like you said, either the equator distance, if it is that model, the equator distance would have to be different, or the distance from the equator to the North Pole would have to be different. But the thing is how it linked into the perspective we were talking about is that, okay, if you put the 3959 as the altitude of Polaris and you move away from it and you call it the apparent altitude starts to go down and use that 3959 for that, essentially like the altitude of Polaris, quote unquote, not saying that it is physically there, but if you treat it as that, optically it seems to function with, in terms of the way that it drops, the 1 degree per 69. And then the 6210 number ends up being, with a planar stationary Earth, would end up being like, if you were to go from the horizon up to directly above your head, up to your zenith, that arc length. So instead of from the equator to the North Pole on a globe, it's from the horizon to the zenith on your visual dome, essentially, your visual sphere, is what that distance would be. And the thing is when you get to the equator, which is claimed to be the 6210 ground distance, that's when Polaris disappears. So it would sort of be that like the idea would be like that the sky has a 6210 limit with the ground, but the sky functions like a 3959 radial celestial sphere optically. Does that make it's
See,
like
that makes it I guess I don't it's strange that the best way to find the radius of up there, and because I don't get what a lens of 3959 means for an object that is, say, 6,000 miles away, because that would say to me I could drive to the moon. You know, I went on a round the world trip. By what you're saying is, if I can see the moon, if my vision hasn't terminated or done something by there, that moon, it should be a drivable distance from me. It looks very far away because of some lensing effect, but it must be within 3959 in order for it to exist and for me to see it, right? Isn't that kind of what you're saying?
Oh. Wait, say it again. Sorry, I kind of missed it. I mean, I was listening, but a video popped on at the end, and then I didn't hear quite the end. Could you say it again? And Cole,
I feel like you're saying the radius of the sky effectively is 3959. Is that right? Have I understood that?
But it's not really the radius of it's like it's an individual radius for each person looking out. Yeah. None of this you can apply to the sky in general.
Yeah,
it would be like just to kind of try to steelman the idea, like not in like a heated debate style that I'm asserting it, but I'm just trying to say like the idea would be that the sky, okay, that the celestials move as you move in relation to a 3959 limit. But if it is at a 3959 limit, the 6210 number would come in by being like it's like the edge of the limit of the ground and the sky, which would kind of relate to how far you could actually see of the ground layer. But it would be, okay, like, you know, on Walter Bislin's, I'll say it like this. You know how on Walter Bislin's little model, he took the stellarium data, which is azimuthal planar grids with the hemisphere of the sky. And that's essentially what stellarium is too. Now, I agree with what we were saying before. Stellarium doesn't really define what the ground is. It's just using those points of the lat long positions. And yes, those are 1 point, which is why stellarium generally works for a globe model. We didn't really go that deep on this part of it before, but I've just linked back to that in my mind. Because on the globe, you're always at 1 point. And so the azimuthal grid is like a hypothetical azimuthal grid, even though they claim the stars, you know, are actually mapping to GPs on a sphere. But the thing is, you can take all that data from stellarium and put it on a flat grid if you want, which is why Walter Bislin did that and basically threw it on a Gleason's looking type of map or whatever, or Gleason's kind of layout. But when you have all those little hemispheres with the hemispherical base of it, you know, the azimuthal base, you can put that data on, you know, a flat surface and then move it around that surface. And the thing is that with the 3959, imagine that little dome on the Walter Bislin model, that little thing. If the radius of that was 3959, that seems to match with a lot of the geometry. Now, does that mean we can only see 3959? Does that mean that that's something, that's what I was saying, like, is it a lensing effect of the sky? Because the way on Walter Bislin's little model, it's like it moves around with you. Well, that's what the sky does too. As you move, it's almost like the sky moves with you. You're seeing a different portion of it. Now, I don't think anyone's claiming that there's like an actual little dome that follows you around a planar Earth, meaning like a physical thing or something that's like some kind of like some virtual reality trippy thing. But yes, but we're discussing how the sky seems to function. And the thing is, that's where they derived the globe model from, is that this 3959 effect of the sky. And they said, well, hey, actually, let's put that as a radius of a globe Earth, but then you got to put the stars light years away. So that's these geometries that are involved.
One of the things, Gio, with the Walter Bislin's model that never made sense, combined with this idea of the limit to your vision, is you can, in the southern hemisphere, you can take, like, just imagine this dome that you're talking about and put one of them in Australia, put one of them in like South America, right? They can both see the same stars, yet their domes don't even come close to touching. Their domes are thousands of miles apart. How could you say that there's a limit? They can only see inside this dome that's surrounding them, yet they can both see the same star. That just seems like a logical contradiction.
If there were two 4,000 mile radius domes around two people?
Yeah, and they're both looking at the same star. That star can't be that star can't be within 3,959 miles of both of them. That's logically impossible.
Why not? Because you're saying if you try to. So like even if we take that,
they're further than that apart. They're like 6,000 miles apart from each other. So how could the thing be in a place where they can both see it? And it's not. There's worse cases where like the further south you go, the bigger it gets. The bigger this problem gets.
Go ahead.
It's funny the differences in the South. I don't know what to say about it. I'm listening pretty intently.
Well, so what I was going to say, like,
been claimed by
24,900.
These are all hypotheticals that you have no actual values for.
Yes, I do. 6,210 or versus 3959. We've got absolute values.
No, not you. Calm down. Hold on a second.
Sorry. That's fair.
The examples that were just given by, I believe it was Anchovy. He was just saying, like, these people, two people 4,000 miles apart, looking at the same star when the star are 6,000 miles away from each other.
Just imagine two people.
The same star that's 6,000 miles apart from each other.
Let me try to make a simpler example. There's two people on Earth. There's two people on Earth, okay, and the furthest they can see is 100 miles, okay. Now, I just moved these two people, so they're 2,000 miles away from each other, right? But they're both looking at the same object. How could that possibly make sense? Because they can only see 100 miles. They're 2,000 miles apart.
Yeah, I think he's saying like the idea, like if someone's hot micing. Eggshells. To be your voice of choice. Eggshells.
Go ahead, Gio.
Well, I was gonna move into hot mic room unless he can just hear me.
Sorry, I didn't. Yeah, I got it.
All right. Well, I think what he's saying is that, okay, if the radius of our personal atmospheric dome of vision, or whatever you'd want to call it, like putting that idea that it, like if it was 3959, I don't think anyone's really like claiming it as some fact right now. I think we're just talking about, because we're talking about how the geometry works with the 3959 with the Earth and the way the sky works. And what I was saying earlier is like that 1 degree per 69 mile on a planar surface grid that Gleam made that we were talking about earlier, and I posted, that uses a 3959 for like the apparent altitude for Polaris to start at. And then as you move away from it, and that works with that. So we're talking about the 3959, how it relates to, in that case, Polaris and so on. And then how they claim it links to the globe Earth. But I think what he's saying is that, let's just say for a minute, it was a 3959, like the Walter Bislin thing, for example, that I was saying with the little hemisphere dome thing. If you were to make that 3959 of the radius of that little hemispherical dome, what he's saying is that, okay, that means 4,000 is your limit. And he's just saying if two people were, I guess, more than 8,000 miles apart is what it would take. Because if one person can see 4, the other guy gets 4. Well, the thing is, though, it's an 8,000 mile diameter. So the thing is, Pfinky, it actually, because if you, that's what I was saying before. I think I didn't get to.
But their domes can't. If their domes don't overlap, there should be no possible way for them to be able to see the same stars. Correct?
No, but the thing is that the 3959, it may function like that's how we. It doesn't mean that that's where the stars are. I don't think like that idea that it functions as a 3959. For example, like.
Okay, maybe it's just a wording thing. Like we shouldn't say there's a limit to our vision.
No, if it was a limit, if it was a limit, like if it was a 3959 limit, then it expires there. Then whatever is actually, there could be things beyond that of what the sky actually is. Like what is the highest levels of reality? Like what actually are those stars? And then they maybe they're traveling, maybe they're interdimensional, whatever wild idea. And then they're meeting you at this 3959, whether you want to call it a limit. I mean, that's just one idea. Like they're meeting you there, meaning kind of like the idea, like I was saying before, if you're in a little terrarium and there's like a white plastic ceiling where you can't really see through it, but like if you could only see to that white plastic ceiling, there might be stuff out there that's like being projected onto that ceiling. There's a lot of like theories or ideas, but you see what I'm saying? It's like a limit, that where something is engaged there. But the stars themselves may actually be, who knows, at a higher altitude, another dimension. I mean, it could be something else entirely, but it's just meeting you at that 3959 or meeting at that point, which I realize those are all like theories and would have to be laid out. I'm not asserting all that's the case. I'm just saying like the 3959, because if you have the diameter of 8,000 miles, then now you have like a 16,000 mile. And then they, the claim is that, well, with about the 24,901 circumference, but half of that, and whether that's the sky or the ground, how that number relates, you get that 12,000 miles, which would match within the 16,000 mile, complete that you would have, complete ranges. Yes, no.
Yeah, the overlap occurs at that altitude, or you know what I mean? I'm just trying to throw out like your dome changes, so on your angle of what you're looking at, right?
But
like how do we?
You get this dome? Like the question I think we're circling around is we're talking about, yes, it's there. I think we've get into where it is. Oh shit! Sorry.
Yeah, exactly. I know. Is it a physical thing or not? Because I hear what Pfinky's saying.
Yeah.
Like, I get the idea. Because really, like, you would have a 4,000 mile radius. It's an 8,000 mile diameter region, but if it's from the observer, it's really only 4,000. So, I mean, I do hear what he's saying with that. And if you're doing that, you only got 8,000 miles. So now, if you can see half of the sky, let's say the 12,000 mile, half of the 24,901, or if the sky functions like you can see half of that 12,000 mile distance, then you now have an 8,000 mile region, and therefore that issue he was saying, how can two people see the stars? But then, like I was saying, it brings in, okay, well, if the stars are all like on someone's actual local dome thing, well, then yeah, that would be a whole different, I guess, idea that everyone is seeing their own unique stars on their own unique dome. But
so I just posted in chat.
And the other thing is that the dome is closer
16
to us and the stars are further. I'm saying the other way to see it is that the stars may be way out there, but then we're seeing, and there's an effect of only seeing them, and then there's a meeting place there. But yeah, go ahead.
I was just gonna say at 16 after the hour, I posted. It's kind of a poor man's visualization of what I was talking about. So these are this is the limit of what we're seeing. Yet both of these people, it's easy to construct versions of this where two people can see the sun, two people can see the same star at the same time, and it's clearly there's no way you can position those where they could see both of them. So I think the idea of like a limit of vision feels like at best it's just a misnomer, because we obviously can see things further than 3,959 miles away.
A hallway, and how far do you see? I don't know what I want to estimate, but and then you move lights around. I mean,
Polaris disappears at this, if that distance from the equator to the North Pole is 6210, and Polaris disappears at 6210, then would that not mean we're seeing at least 6210? Because I mean, if you can't see any stars beyond 6210, then that's the limit. Wouldn't that be? I mean, meaning like that you can't see anything more of the sky past that. Granted, if you go up in altitude,
it could be the case. It could be the case, but I still feel like you could expand these domes to be 6210, and you're still going to find places where they don't overlap, and yet people see the same. And it does seem like, I didn't think about that, but that is a conflict with at least with Gleam's spreadsheet and what Shane's doing, because they have there's conflicting limits to vision, I guess.
Yeah. Well, let me ask you this: if the actual truth is that we're on a stationary planar surface, but we see, even if, like, what did you call it earlier? You called it dark angles or something. Dark. What is Issa calls it? Dark polarity. He jokes around.
It's what Gleams said it. We got on chat one time, but he said it as sort of a joke because the globe always invokes dark matter as sort of like an explanation and to explain something that can't be explained. So he invoked it as a way because he knows what he did, and he just said, "Oh, it's dark angles" as a way to sort of sidestep the issue. Those are I don't think he's serious by it. It's sort of like a tongue-in-cheek thing.
I gotcha.
Also known as mirror angles, maybe.
Well, like I said before, like I think that they're like what you're calling an so you're calling incongruent the 6210 versus the 3959, or are you? I was trying to Steelman you through a lot of that when I was trying to ask if this is what you're asking. But
oh yeah, I'm just saying like Shane's diagram with the dome over it shows that the limit of vision is 3959. But and this probably goes to Eggshell's point about the difference between the arc length and the radius. But Gleam's very clearly like we can travel to the equator, which is 6,200 miles away, and still see Polaris. So yeah, I think we should be able to say we can see that far.
How far do you think you could see Polaris if you go up at altitude south of the equator? Like if you went to like, you know, I mean, you got like 35,000 foot airplane, you got 60, 70, 80,000 like custom airplane situations. And then like, you know, but like if we started launching balloons south of the equator, 130,000 foot balloons, how far do you think we could see Polaris from further than 6210? Like, could we get to 6,500, 68, 64? Like, what, you know, how much beyond 6210 could we see Polaris if we went up in altitude? That's the question. It's just kind of a rhetorical question, I guess. Like, we could pull out the math and crunch it, but I'm just saying, like,
yeah, I know, like, when
that's actually a good experiment. That's a good experiment.
It would mean that yeah, that is a cool idea. It would mean that you could see further than 6210, but that wouldn't be a limit either. If you can get, you know, 6,400, 65.
Well, part of the problem too is the Polaris thing, the 6210, by the time it's on the horizon, that's like a flat, that's a, I mean, I guess you can consider it like the hypotenuse where that value would be the same all the way up, but yeah, never mind.
Balloon that high, there's no way you could keep the camera steady enough to focus in on Polaris. This just wouldn't work.
Why not? We could launch a balloon.
Have you tried looking at Polaris through a telescope on Earth? Like on the ground?
I mean, I do hear you with all the like atmospheric conditions you're saying. It's not.
Yeah,
it's
just like
it's not the
trying to
brightest
keep the
star.
balloon steady, because like the whole balloon has to be dead still for the camera to focus on Polaris, right? And how are you going to focus on Polaris? You're going to have remote control camera as well, I suppose.
Yeah, well, you need a sick gimbal.
A gimbal,
auto balancing
multiple cameras or 360 cameras or both. Yeah, to be able to film basically the whole sky, or unless you could control the balloon or the position of the cameras, like if you had like servo controlled cameras as well. But yeah, that would be quite a project to do all that.
I don't see it being much different than like you've seen the videos of people that have drones. They fly the drone up and bring the sunset back into view. It's going to be roughly the same. I think it'd be the same for Polaris. Sun would be a lot easier.
Easier, right? Yeah.
Yeah, so the ground executes with the sky at 6210. If that distance from the equator to North Pole is 6210, if we were able to obviously double, triple check that, make sure that that's the case, and then if you're on the ground level, although Polaris can be seen further south than the 6210, even on the ground, you know, Polaris in some cases can be seen past the equator. And I know there's contention as to how much past. I think the mainstream even admits at least a couple degrees, right?
What I asked this question earlier before Lion jumped out. What do you think happens when we hit this limit?
You You've taken a lot of DMT and you're meeting the creator.
No. I mean like let's say
when you go to the what you mean beyond the heavens, like.
No. I'm saying I'm looking at Polaris and let's say the limit is 6210 exactly on the nose, right? I take one step backwards. What happens?
Wait, say that one more time. Sorry, I was fixing the live stream.
Let's say I'm at the limit of our vision is 6210. I'm looking at Polaris and it's 6210 away, and I take 5 steps backwards. What happens?
At the equator, like when Polaris starts to disappear?
Just anywhere, because it's the limit of our dish. It's not just about Polaris. It's anywhere. I'm 6210 away from anything you could imagine, and then I take 5 steps backwards. What do
My
I see?
understanding is you can see a bit more than 6210 because, I mean, the globe claims refraction. On a planar surface, there wouldn't. Well, you could still have refraction, but you wouldn't have to be seeing because on the globe thing, you have to be seeing around the curve, essentially, because at the equator is where the curve starts to actually intersect, or the claimed curve is intersecting with Polaris. So you can't actually see it because there's physical Earth in the way. But then you get into the whole refraction idea. That goes back into like cell Theo kind of stuff as well.
I'm not pinning you down to a distance. It's whatever the distance is, call it X, right?
Well,
but the claim is that there's a limit to the limit to how far we can see. So my question is, when I go X plus 5 steps away from it, what I expect? Like, what is the implication of this limit?
That's perspective limits, not vision limits, but perspective is part of vision. How far you see is due to many different factors. One being perspective. Refraction plays a part. Visibility. I mean, you can have something obstructed. You might not be able to see it from 200 feet away if something's in the way.
I agree, but I think the argument is that all things, perfect conditions, everything, we just physically cannot see anything more than X distance away.
Yeah, that's based on perspective in a vacuum. Without any other factors, prospectively, as you move away from something that's directly above you, 6210 or whatever the distance is, you no longer can see it in your vision because it's gone down so low in degrees you can't see it.
Well, that's not the case because you could put, like earlier we were doing this math. You can put, if you put the sun at 3959 miles above you and you go 6210 away from it, it's only at 25 degrees. Like it doesn't go down near the horizon.
Either. Yeah, because you're viewing it not in a vacuum. And I don't know what the claim is, to be honest with you, but I'm not sure if it's just terrestrial, all celestial, or everything. But I mean, you're not going to, the whole point is you're not in a vacuum when you view that one object. You're not in a vacuum when you view any object. That's why there's many factors other than perspective. But
I'm not arguing the point of how far we can see. I'm just asking the question, what happens when I go beyond that point? Does the thing just disappear? Does it fade out? If I take 5 steps back and 5 steps forward, does it come back into view? Like what happens?
It sets.
Depends on what the object is.
It sets. It's setting.
Yes, that's yes.
Essentially, I mean, it's similar to setting, although we usually call something setting like when it's moving in the sky, like the celestials, like the sun sets. We say so, like the sun itself is moving and then it sets. It's the sun doing the setting. Well, in this case, if we're talking about Polaris, which is like I mean, it does move a little bit, but it's more or less in one position, and then you're actually walking away from it, causing it to have that setting effect. Then it's not because of the motion of the object setting, as you're watching it, it's you causing it to have that setting effect by moving away from it. So yeah, I mean, once you get to the equator, I don't think it's like a clear cutoff like that though, because the horizon, usually there's haze and all the conditions. You have that, of course, like not everyone is like on the ocean. So then you have elevation. So usually Polaris will probably be setting before the equator, just because you're usually at some level of elevation in the land differences. And then you have refractive effects, which they claim is why you can see it when you go even further. Is on the globe they claim refractive, but on a planar surface you could also have refraction, but you wouldn't really need refraction to bend it around a curve. You're just able to see it further on a plane. But I mean, yeah, it's going to set in that region around the equator, likely depending on conditions. But I don't think it's going to be a 5 foot thing though. You're not going to be able to watch 5 foot Polaris sets 5 feet forward, it's back into your vision. 5 feet, it sets. That'd be amazing if you could get that much accuracy. We should do that test too.
That makes sense even on a sphere, actually. Like, you know, even if you're on the open ocean, you're going to have mountains and stuff in the distance, you know, that would block it. You know what I'm saying? If it wasn't projecting itself to you. And also, it depends on the object, because if it's not a bright light or a big object, you're not going to see it that far anyway. You're not going to see a pinpoint light 6,000 miles away, no matter how high it is in the sky or above you or whatever.
Okay, well that answers my question. There's a limit to the distance that we can see, because as we get further away from things, they move down an extra amount on top of perspective, and then they go out of, like, basically they set.
I don't know why you said extra.
Is that a fair Steelman?
Well, except for the extra, because there's only certain things that you claim are I don't have that claim because I don't know that as a fact. But when you enter in refractive effects, like was just clearly explained by Geo, of course it could be more than perspective. It's always more than perspective. It's never one thing, but you can prove perspective. The one thing I want to point out to whoever's listening to this conversation is that when the model talks about, in the spherical model, talking about the North Star Polaris or any other star that you move away from that supposedly is stationary, it has nothing to do with perspective, because they say it's Earth curve that causes that 1 degree per 69 miles, because you're going down a curve from the point that you started at. So the star is stationary and you're moving down, and that's why it gets lower in your vision, which makes no sense, or you're rotating or whatever it may be. But they say it's because of the rotation and sphericity of the surface you're moving away from the star on. And they take perspective away and say it doesn't count because the star is so far away. But perspective doesn't care about distance. If you can see it, that's in your vision, then perspective should be included.
I mean, perspective still applies to stars. It applies to moon. It applies to sun. And we'll get things like parallax with all three of those, albeit at smaller scales. I just think it's important. This isn't like as a debunk. I think of, like, if I was a flat earther, I think acknowledging the fact that perspective, at the distances we're talking about, perspective can't make the sun set. It needs something extra. And so I think, saying like there's a limit of vision or something that for each observer makes things go lower in the sky even than that, then that would at least deal with that problem.
I'm going to hold you to your claim right now. You went through many different claims just then when I tried to get you to hold on. As soon as you said perspective does apply to the sun or North Star. Okay, as you move away from the North Star, any amount of miles, how much perspective in degrees does it get lower in your vision?
Effectively none. Very tiny amount.
So perspective doesn't apply to the North Star when you move away. So your claim
it does. It's just a tiny amount. It's.
What do you mean? Okay, what's tiny? What amount?
However many light years you can make the triangle. You can make the triangle apply as much precision as you want and come up with a number, and it will be something.
Parabolic.
1,000 miles.
I mean, the moon, you can take the moon, you can go on opposite sides of the earth and take pictures of the moon, and you'll actually get different angles on it. It's visible. Here, I'll post it. I'll post it in chat.
You can take any object in the sky and go on opposite sides of it. You're talking about the same distance? No, that's not true. If you go, how would you even know what position the moon was in? Like, have you ever been directly under the moon?
You just take two people. You take two people as far apart on Earth at the exact same time that can both see the moon, and you have them take a picture of it, and you'll notice that they both capture a slightly different angle. That's not true of the sun, because the sun's further. That's one of the ways that we know that the sun's further away.
Which one of them are in a vacuum?
Neither, but the amount of parallax is like, we can repeat this. It's very predictable for the moon.
So each one would have different conditions other than perspective, right?
Correct, but the amount of parallax we could repeat this, and yes.
Yeah, that was easy.
Well, why doesn't it happen for the sun then?
What do you
Same
mean, why
viewers,
doesn't
they
it
can wait
happen?
till there's parallax for the moon. We can wait for the sun to come out. Now they can both take a picture. The sun doesn't have the same parallax as the moon. Same conditions.
That's a claim that I've never seen. I trust you, right? But I'm sure there's a good reason for it. I mean, there's always a reason for all things, right? Like there's more than one reason or more than one theory or whatever. But for you to prove that is just it's a tough
Prove
thing.
what? Like I'm just telling you, like observe. This is observable reality. Any of us can go do this. There's plenty of cases of people like taking these photos of the moon. I'll post some right now.
I can have the sun in my sky as a white dot because I have fog in my area, and someone 100 miles away can have it as a bright yellow sun. That doesn't mean that we can be the same distance away from the sun, which is ignorant to say because there's just no way to prove that. But
it's not about distance. It's not about distance. The point of the moon parallax is
like, are you comparing sunspots? Is that how you're observing parallax?
Yeah, that was sunspots would be one of them. The moon, there's known moon features, so we can compare those. But the whole point, like parallax, is used by the military. The closer something is to you, the more parallax you get with distance. So this is a way that we have used to like triangulate and find positions and distances of things prior to having like laser rangefinders and all that.
Set a sun in a fucking hallway, bro. Like, I don't mean to use the F-bomb there, but slide a light down the roof or the ceiling of a hallway. How long has it got to be till that thing disappears and you get green light out of it?
What's the material made out of?
Plasma. It's a giant welder's torch, a 6 foot.
It would have to be plasma to get the green flash, correct?
No, that's called when you're at convergence point, you're going to get that angle regardless. I mean, no, you're right. Point source got to be pretty bright, but what is the sun as a light source?
But the thing you're getting the green flash from has to be a specific element to get the green flash, right?
No, I don't. I think that's in the.
What do you think? Why do you think that? Why do you think that?
To yellow to white to green. I mean, that's just how colors work to the eye. I see it. Obstruction, you see green. When there is obstruction. Yeah.
I'm not sure the hall. Like, what's the point with the hall? Is it that we do see things drop down to the horizon in a hallway?
No, it's that the fact that if you had an infinite hallway that did not appeal to curvature, at some point at the end of the hall, your convergence point would be near the ground, and you're going to see a green flash based off of their own worldview.
No, I didn't mean to combine those. I'm saying the walls, the floor, and the ceiling go to a point, and it's a shorter distance than you think. I don't
walls
know.
Are
well, you can do the math on it.
On the green flash. Is that true?
Forget the green flash, but we can put lights on the walls.
Well, no, I liked your green flash. I think that was a part of your argument for why it happens at the distance it happens. Don't just throw it out with the bathwater. Like that seemed to be like one of your defining points. Like, right?
Well, people
is it the ceiling that does that, or is it the walls that do that?
Well, yeah, no, I'm just saying, like, people don't believe in a green flash. First of all, they've like never pulled it off to see it. But I don't know.
I've seen the green flash. What are you talking about?
Flash or just green sun. So, but a ceiling light, yeah, if it was a pretty bright halogen with I don't know how many gigawatts. But yeah, you
gigawatts. How many gigawatts? We're going back to the future.
80 miles per hour, Marty.
So 24 ounce. This is the way I look at it. We know there's one thing we know, that when the sun is 6210 miles away from us, it sets. Right. So now all you have to do, you can choose a height. You can pick any height for the sun, and then we can move it that far away and see how many degrees in the sky it would be. And it's not going to be close to zero. I guarantee it. Unless you put the sun at like 20. If you think the sun's 20 miles in the sky or 5 miles in the sky, then it would. But if you put the sun at 3,000 miles up in the sky, it's not going to get down there.
I know, yeah. I'm kind of at the lower end, so I don't know, man. I'm just making that kind of perspective point, but I'm mixing a couple things. Those are good.
I'd like to make another statement about what I've learned over the years in this debate, and most of the people who believe in the spherical model don't even know this, and I don't know it to be true, but it's stated as fact often, is when you're watching a sunset and you barely can see the top portion of the sun right before it sets. On days that it sets that way, because other days it doesn't, because of the conditions, it's already set. It's being refracted up.
Right, that's the point. What are you seeing? I guess, yeah. Like,
anyone got a drone? I've actually done a
light.
sunset. I've actually done a sunset blank here in Minnesota. Like, so the sun sets a little bit differently because we have a horizon line based on trees versus like water depth or whatever. But I've watched the sunset and then I threw my drone up and made it double set the sun. Has anyone else done that?
Yeah, the skydivers.
Out at sea level. It
Well,
didn't
Raqia,
set.
have you ever
It
done that?
faded out.
Raqia, have you ever done that?
I've never taken a drone at sunset, no, and done that. I want to.
No, you should try it because you can make the sun come back if you raise an elevation. It's kind of
That's why
interesting.
you don't have friends.
Yeah, it's not coming back.
Wait, who said I don't? Wait, who said I don't have friends? I have Cole's my buddy right here. Cole, are you my friend? He's probably
right.
You're changing your viewer height, which changes perspective. It's actually proof of perspective, not of anything else. Or it doesn't mean that the Earth is not spherical. The sun would set on a spherical object, but it still has perspective. So on a flat plane, it would also.
I was just going off what you were saying. Yeah, no, I agree with you. You're definitely gonna have perspective, and it's gonna be based on your height, which is why I said if you threw a drone in the sky, you could actually watch the sunset, throw a drone way up there, and then watch the sun come back and watch it set again from the drone's perspective.
Yeah,
but you have to have friends to do that, apparently.
I don't know how many sunsets and sunrises I've done. It's thousands, and I've seen the sun in many different shapes. It always doesn't just set the way you realize the sun is. Like most sunsets are what is shown, but there's some amazing sunrises and sunsets that look like mushrooms, look like keyholes, fade out, like blink out, like they're a light would if it's getting further away from you, and it's based on the conditions of the day.
Yeah, the clear ones though, the top tier. I agree with the drone thing. I mean, can't you zoom in? Couldn't you zoom in enough? Like with ships?
Yeah, why does bring my like, so I can be with the drone and I can zoom in, the sun is set, but then I can just be like, I can't zoom in. I can zoom in or zoom out, it doesn't matter. But then if I raise the drone up, the sun comes back up, and I can do that probably like 2 or 3 times actually within like a 10-minute period of the sun setting, where I can't see it physically, but if I just keep raising my drone up in the sky, I can't zoom in to see the sun, but I have to raise the drone in the sky to see it. Why is that? That's kind of weird, right?
No, if you can do it a couple times, how high are you going? And like we can calculate how that angle's working.
Yeah, 4,000 feet. Legally 4,000 feet.
Then, because you could go even higher and not see the sun because of how dense the atmosphere is over that distance, right?
Oh, really? Have you done that? Because whenever I take my drone up in the sky, there's no point at where I can raise it into the sky where I can't see the sun. That's kind of, as long as the sun's out and I can see it. If my drone's in the sky, it also can see it. I've never been able to raise my drone above the level of the sun, but you have, or you've seen evidence of it, and I fucking would love to see that.
Well, I think he's saying something different. I think he's saying that there's conditions low. There might be conditions where you are, and then when you raise the drone up, the drone escapes those bad conditions and then can see the sun again.
There will never be a condition though where I see the sun and I raise the drone up and the drone doesn't see the sun. Is what I'm saying.
How does your drone fly again? I'm confused.
4,000 feet, he said.
No, 4,000 legally. I can definitely go higher than that, but that's legally. So you can. Depending on the drone and how fast it can raise and to catch the setting sun, you can catch almost 2 or 3 of them. Lowering is actually harder to do because it can't drop down as fast, but you can raise up a lot faster. You can catch a couple drone sunsets when your eye can't see them and you can't zoom in to see it, but just raising the drone will make the sun come back.
I don't disagree with that at all. Either model, that would be true. So I don't disagree with that, but everything has a limit. You can prove this with a smaller light. You know, you
if I was on a flat Earth and I put the drone up, if I put the drone up on a flat Earth, I could just zoom in to see it. Why can't I just zoom in to see it?
That's just not true. No, it's not.
So what causes it on a flat Earth for me raising the...
You think light travels forever, and I don't know why you're so excited and cutting me off.
Well, don't put words in my mouth, Raqia, or I'll do it to you. You like drinking. You like drinking pee from other people, but I won't do that to you. So don't put words in my mouth.
I didn't say
don't put words
like
in my mouth. Don't say I like things or you don't like. I'll say you like things. I'll say you like all sorts of things. Don't do that to me.
What are you doing, bro? You sound terrible.
You just started saying I like all sorts of things. You don't have to do that. Just make an argument from your point, and I won't put words in your mouth. I won't put shit in your mouth either.
That's the only thing I'm doing is making the statement.
I won't say you believe things until you say you believe them. So don't say that about me, Raqia.
Is there any mod here? This is ridiculous.
Yeah, there is, but you have to understand the position I'm in. I either have to mute him and he's out of the convo, or I have to come in and repeatedly ask him to not do this. So please understand the position I'm in. Yes, there is a mod. Demon Stride, could you please not do that? Because we're in a good combo. Can we not do the interruptions and personal attacks, please?
And if Raqia could not do them too, that'd be great.
Yeah, I mean, he was doing it to me. It's fine. Hey, Gio, I'm fine with not being interrupted. I'm also don't want to interrupt other people, but he literally said,
leave the room.
I'm sorry, Xprog. Gio just asked you not to interrupt me, right? Come on.
Just reset.
I was just asking him to not. Oh, I'll mute, and then tell me when I can talk.
Well, I'm just saying, let's just reset. Just reset.
Yeah, we can reset.
I was just gonna say, Raqia, but please don't say I believe things, and I won't tell you what you believe. We could just let the VC decide.
I don't think those words came out of my mouth, but if I did, I apologize. It's not what I'm trying to do. I was just, I'll try and get this out. But I do believe everything has limits. I don't believe light. You can see light forever. So the claim that on a flat Earth you would be able to see the sun no matter what location on Earth you were if you got high enough. I don't believe in that. I personally don't believe that because I can prove to myself that a smaller light you can't see at even like short distances. A candle, no matter how high you are. No. Oh my God, bro! I'm out.
Yeah, I think I was actually gonna. I liked what you said there. So, are you saying that there's a certain height? Is maybe less atmosphere restrict more light for you? Because I think if you get out of the atmosphere, you have less dense atmosphere. You probably see more light. Or do you disagree with that?
Well, I do agree if you're trying to make the point that the lower you are, the more dense the atmosphere is. But also, when you increase distance, no matter what the degree of density you're in at that time, when you increase the density, the layer just stacks on itself. Like, you can see through a less dense cloud, but if you put a more dense cloud, that same density cloud, behind each other, you're not going to see through all of them. The light's not going to push through all that atmosphere, no matter how high you are. Yeah, that's my point.
Well, right. So I kind of understand what you're saying, but like if you imagine like the angle you're looking at a ball, like you're either looking into the sky or you're flying high in the sky and you're looking down over the other edge. You're either you're ultimately looking through almost the same amount of layers of atmosphere. But why does one work raising an atmosphere to see the sun, whereas if it were a flat Earth, I should technically be seeing less layers of light that I'm looking through. If it was flat all the way through, every layer my drone goes up in the sky, there will be less dense layers stacking against each other, correct?
I guess. I mean, I can't really prove that to you, but I think I think you're accurate in that. But I think the sun on a flat plane would be, and even on a spherical model would be moving away from you, or you're moving away from it. So either way.
No, it would be further away from you. You're right. It would have to be like the whole like length of the Earth away from you if it was flat Earth. And with that, you might be able to argue that there's like a much longer gradient of density you're looking through than you would even on a globe Earth. I think that might be where your argument could be best landed at.
As far as you understand, both models I think have good points. I don't disagree that a sun, no matter how far away it is, would set on a spherical model. I mean, I don't. I can see it, right? And it would look very similar, I think, and it would have some of the similar effects of being a different size and shape and color depending on the conditions, even on a spherical model. I don't doubt that, but I can see it both ways.
Oh, I must admit. Sorry. Did you say you couldn't see how the sun could set on a spherical model, or you can? I might have misheard that.
Forcing to it. If something goes over a hill, you can't see it anymore. I get it.
Okay. No, I think we're both understanding it then. I think maybe I don't agree with your assumption that there'd be a stacked layer you couldn't see through. I think on if you imagine a rainbow, if you're on one edge of the rainbow and you're looking through the stacked layers of the rainbow to the other edge, I think you're looking through a bunch of stacked layers. It might be hard to see the sunset. But if you raise like from the Roy G. Biv all the way up to the V and you're looking through that, you're seeing through less stacked layers on a curved surface. And I think that's a good analogy to express why raising the drone, you're going to be able to see the sun, even if it was on a flat Earth. And I don't know.
It's called they call it a gradient index. It's like a different type of refraction.
Well, I don't see how something can sit behind the horizon on a flat Earth anyway.
But going up out of a dense layer or not? Is there no light escaping?
It doesn't set behind the horizon like a horizon being a physical thing. It doesn't do that.